Hello everyone, how are you all? I hope every one of you is doing absolutely fantastic. This is your chemistry expert Sanjaya sir, and today in today's session we'll cover second part of this analytical chemistry, which is practical inorganic chemistry. We also call it salt analysis. Hopefully I'm pretty much audible to every one of you. Let me check if I'm audible or not. I am pretty much audible. So guys, what I'm telling you, for your better clarification about this chapter, do not skip my previous one, which was practical organic chemistry, where I taught you several techniques of the separations of the compound. That is something that will be used like even in this chapter. And right after that, we have inorganic chemistry with us. Usually some of these salts which contain two type of entities in them. One of them is cation, another one is anion. We call them basic and acidic radicals respectively. So we are about to identify that what salt has been given to us and how can we confirm that what anion and cation was present in this salt. So this kind of thing we are going to conduct for our upcoming this lecture, and we'll complete this chapter with so many ions which are in our syllabus. So let us first go through what is in our syllabus and what we have to cover. So this is the chapter about, we have salts, and salts are composed of two things. One of them is called as cation. So guys, we all know that cations, when accepting the OH minus, can form MOH and become base. So guys, a base has basic radical. So basic radical is basically M positive. In the similar way, let us suppose some anion BX minus, which upon accepting H positive gives you HX, and HX being an acid has X minus as a acidic radical. So this confusion of acidic and basic radical can be resolved from here, can be removed from here. We have qualitative analysis of inorganic salts. There are a set of inorganic salts that we are going to conduct some tests in order to identify what ions are there in between. So qualitative analysis means the identification of the cation and anion present in the salt or the mixture of salt, and is carried out through some of the basically easy perceptible to our senses, some of the things which are going to do, just like such as our sight or smell, just like the formation of a precipitate or change in the color or evolution of a gas. These kind of basically changes will be seen to confirm what kind of compounds have been given with. So guys, this is just an introductory part till now, and now I'll give you this idea of what is in our syllabus, what we have to cover up with. This is the syllabus of JEE Main 2025, and we have to complete this much number of cations and anions respectively. In terms of cations, we have lead, Pb2 plus, Cu2 plus, Al3 plus, Fe3 plus, Zn2 plus, Ni2 plus, Ca3 plus, Ba, Mgn, ammonium ion. Anions we talk about, we have carbonate, sulfide, sulfate, nitrate, nitrite, chloride, bromide, iodide, and insoluble salts are actually excluded. So there are insoluble salts, just like sulfate ions are there. So lead sulfate, barium sulfate, these considered as the insoluble salts. So their study has been eliminated out. But anyways, we'll try to cover all of the ion, even including those kind of ion which are precipitate, and we have a separate process of identification of these compounds. So now our aim is very clear. We got to basically detect the one cation and one anion out of the salt of the following ions. These are the cations and anions. Insoluble salts to be excluded. This is the syllabus given to us. What is the theory basically? And how do we proceed with this theory, everyone? So guys, mainly there are two major principles in salt analysis that we use. The very one of them is called as the solubility product. This solubility product helps us to define what can be precipitated out in what ions presence. We all have heard about ionic equilibria and the solubility product, and we all know that whenever any ions or the ionic product of the ions becomes over or more than Ksp solubility product, that particular salt gets precipitated. That is what we'll be planning for. Also, selective precipitation will be conducted out in the presence of common ion effect. So this is what the proper principle about this salt analysis will be gonna to use. These two are the solubility product and common ion effect. Hopefully this part is absolutely clear to all of you. Till here we haven't taught anything, just taking the basic introduction of this chapter. Everybody needs to write down everything whenever we are making a notes out of these. That will be highly helpful, especially in this chapter. Let us just start. How are we gonna to take this salt analysis, in which way? So guys, we have been given with the salt. You might have seen this thing even in your schools, like during your practicals in chemistry. You have been given up with 1 gram of some salt, and that is wrapped in a paper, and you even have no clue what is this compound all about. What you are gonna to do, you need to basically go for some of the preliminary test and confirmatory test. We have two things here. Preliminary test means pre-test, that is to be done like very quickly in order to get an idea what can be the salt over there, so that if we are very much kind of like a bit sure about like this could be the ion, we can go for the confirmatory test. So this will save our time, no doubt. Also, confirmatory test is the test that will confirm the presence of that particular ion. So we have two tests. The starting one is preliminary test, also called as dry test, that is conducted in the dry state of the given salt, and examination of the salt or the solution in its dry state. And then we have confirmatory test, the another, which has to detect and also called as the wet test, and that is the determination of an ion and cations by some of the specific reaction carried out. There will be some specific precipitates will be formed, that will be observable. Some gas will be released, that will be observable. Some odor or smell will come up, that will be observable. So we are going to conduct these tests respectively, one after one. Gas respectively, one after one. Okay. There is one thing that we should note over here, that whenever we are going for the analysis of the salts, analysis of anion is actually performed first. Sometimes we think that cation and anion, this is how a salt is made of, but anions are actually done with their test very first, then only cations are done. This is because that some of the ions are there, some of the anions are there that interfere in the detection of the cations, especially of the group 3 and beyond that. Let us just read it first. Then at the time of the group 3 cation we will be studying, I'll explain this part to you. So anion is performed first because of this, underline this part, that detection of the cation, because it's if there are any interfering radicals like fluoride, phosphate, oxalate and borate are there, it's present in the given mixture, then they will interfere the test of third group cation and onwards. So this is something what we follow. We first need to examine, or analysis must be conducted for anions. Right after that we can go for the cations. In any of these interfering radical is present, if any of these interfering radical is present in the given mixture, it has to be removed before performing the test of third group and onwards. Otherwise they will interfere and the confirmatory test will be disturbed anyhow. Right? So just write this thing down, not this part, that these anions are the one which are major responsible anions, for which we are conducting the test of anions first, and right after that we are going for the cations. Now we have preliminary test, and we also call them dry test. What are the dry tests? So guys, preliminary test of salt often furnishes some of the important information, and that simplifies the further course of analysis. So like if I only have an idea that this might be a salt or this might be the cation over there, if I go specifically for the confirmatory reaction of that cation, that will save our time, that will give us a precise of the information. But if we are like clueless about what salt is it, and we have not conducted the dry test, it will become highly difficult for us and very what should I say it, time taking for us to go for the confirmatory test. Then we have dry tests are not conclusive, although when we go for the dry test, everyone, we will find multiple results which may what should I call it, contradict to each other, which may sometimes contradict to each other. Just like in borax bead test, we'll find a few of the cations, a few of the anions, a few of the cations are having exactly the similar kind of color, blue color, and that has been showed by so many radicals over there, even cobalt 3+, Mn2+, sometimes so many other cations are there, they also give you the blue color in their oxidative flame. So that is something that we have to take care of, that these are not conclusive, but yeah, they may give us some idea, and when we are getting some idea, we can lead with we can go in the direction of confirmatory test along with that cation. So that is what we have to follow, but sometimes they also give you quite important clue, and they can be performed within 10 to 15 minutes. They do not take too much of time. So now, what we have to follow while following this preliminary test: the general appearance and physical properties such as color, smell, solubility, etc. of the salt is something that we got to note about. This is something where we are about to note. This is involving the noting of these properties of the salt. Then heating of the dry salt, blowpipe test, flame test, borax bead test, sodium carbonate bead test, we have charcoal cavity test. This is something we are going to perform in the analysis of the cation, especially in our coming of the chapter. We also must take a note over here that preliminary test should always be performed before starting the confirmatory test. Otherwise, you cannot directly go for any confirmatory test until unless you're known about what cation and anion are there. You cannot go for any of the confirmatory tests. And there are like lots of number of tests involved in it. There are lots of number of ions that exist. We cannot just randomly pick anything and can start it with something. We must have some clue about what we are going to perform with. And that clue comes only from the preliminary test. So that's why preliminary tests are highly important. We call them dry tests also. We have classification. Everyone, do maintain this thing in your mind that classification is highly important. Classification simplifies a majority of the problems in your coming chapter. So classification means in which categories we have divided these ions. First of all, we are going to classify anions because we are going to analyze first of the anions. Later on, after anion, we go to the cation. So these are the classification of anion. What classification are we following here? So classification is broadly made under two categories. The one category says that which is gonna to give you the volatile product with acid. Now this acid can also be of two types. This could be a dilute acid, this could be a concentrated acid. Those kind of anions which give you a volatile product just with the dilute acid are kept under first A category. First A, 1A category we keep them under. We have another called as second A. So second A is the one that will give you a volatile product with concentrated acid. And we have these cations, these anions, especially carbonate, bicarbonate, sulfate, HSO3-, sulfide, then we have S2O3, thiosulfate kind of, then we have CH3CO2, acetate ion. So these are actually the ions which we have also NO2 ion here over, NO2 ions, NO2- ion, and they upon treating with dilute acid are actually converted to their volatile products, such as carbonate is converted and bicarbonates are converted to CO2 gas. CO2 gas has its own significant, its own basically characteristic property to be identified from. Then as sulfite ion, we have bisulfite ion, then sulfide. These all are produced. Okay. Anyways, we'll cover each and every one of them individually. We have second category of concentrated acid, where we are dealing every single anion with concentrated acid. So those who come under the category of dilute acid will definitely be under the category of second A also, because those who are just normally getting converted into their volatile product or gaseous product using dilute acid, using concentrated acid also, they will definitely be going into their volatile product. So all the first A anion belongs to second A also, but all second A anion do not belong to first A, because in second A only those anions are present which upon treating with concentrated acid can leave you up to the volatile product or a volatile gas. Take these examples, just like fluoride. Fluoride usually doesn't react with acid and producing UHF. It requires to be reaction with concentrated acid, and that concentrated H2SO4 upon reacting with H minus, F minus gives you relatively weaker acid such as HF, HCl. HCl is also a characteristic gas that has its own tests we will study about later on. Br minus is brown colored, Br is converted into Br2 upon oxidation, which is a brown color gas. I minus gets to I2, which are violet color fumes, and upon its condensation it gives you violet colored solid crystals. We have nitrate ion that upon reaction with an oxidizing agent or concentrated acid gives you nitrogen dioxide, which is a brown in color. Oxalate gives us a mixture of carbon monoxide and CO2, and all the other anions which belong to first A are also a part of second A. So there we have this classification of anions up to which of them can give the volatile product with acid. We had two categories, first A and second A among that, but now we have another category, B category, where there is no volatile product coming out of an acid on reaction with acid. There is no as such volatile product, but what is there? We have to identify on the basis of the chemical reaction in the aqueous solution. So in aqueous solution there could be two possibilities. One could be the precipitates, like sulfates are precipitated, phosphates are precipitated, right? Then another one could be the one which will be showing you redox reaction. So like MnO4 minus is pink in color, MnO4 2 minus is green, CrO4 2 minus is yellow, and Cr2O7 2 minus is orange. So right after like these ions, whenever they are capped into acidic condition, right? So this is how they give the test. So what I'm saying is, let's suppose this is a chemical reaction and MnO4 minus is actually showing you pink in color, and right after treating it in the acidic medium gets converted into Mn2 plus and becomes colorless. So guys, once the color will be changed over here from pink to colorless, you will be confirming it using your preliminary test itself that yes, right now we are given up with the permanganate ion, MnO4 minus ion. So just learn these: dichromate ion, chromate ion, permanganate ion and manganate ion. These all are the examples of the redox reactions where we have to check them, we have to check their presence or their availability by using their chemical reactions. Note it down, everyone. Please try to note this thing down. Maintain your notes properly. This is what I have come up with this, and this is purely in CRT lab manual we follow, and from that only I have made these notes. That's why you can see some of the snips here. Some of the snips are not even of good quality, I can see. Now see, what is the first step? What should we do? We are performing some experiment now. This is called as step 1, preliminary test with dilute sulfuric acid. We require dilute sulfuric acid. Why do we need it? I'll let you know. By the way, dilute sulfuric acid does one thing. Dilute sulfuric acid, once it is first of all, it is working as an acid, and in acidic condition it can convert some anion into their volatile products. The another thing could be it removes the impurities present over there by oxidizing them into their gaseous product, which can leave the mixture with impurities will be left out. So we have in this test, in the test of reaction with dilute sulfuric acid test, there is an action of dilute sulfuric acid and procedure is given over here below. So on the salt it is noted at all the room temperature and warming. Carbonate ion gets converted into CO2. Then we have sulfide ion, nitrite ion, acetate ion. These all react with dilute sulfuric acid to evolve different gases. Their study of the characteristic gases is done, and what are to be done, what I'll let you know. Guys, this is not supposed to be learned. This is not we are going to learn, because this is the experiment which are given to us. Not required. You can skip it out, because we are not supposed to learn down how we are conducting the experiment. We are not conducting the experiment here. We will take the idea how does it go. So like we have taken 0.1 gram of salt, we have given it 1-2 ml of dilute sulfuric acid. Observe the change. If there is no change at the room temperature, then heat it. If any gas is evolved, then go for the further test. If not, then then like further heat it. If the gas is evolved, it by using the apparatus shown like this and identify the gas evolved. So there we go. So let us suppose the carbonate ion was given in the initial mixture. The carbonate ion once reacted with dilute H2SO4 gets converted into carbon dioxide gas. Carbon dioxide gas, when passes through lime water, it turns it milky. So that is a characteristic test, everyone. You all must know this is the first test we are conducting. A colorless, odorless gas which when evolved with a brisk effervescence which turns the lime water milky. Lime water is your calcium hydroxide, and this gas passes through reacting with calcium hydroxide producing calcium carbonate, which is a white PPT, remains suspended in the water. Doesn't get dissolved easily. We have colorless gas. Okay, now next is sulfide ion. If sulfide ion gets reacted with an acid, it gets converted to H2S gas, which is a it gives you a very foul smell of rotten eggs, and it also turns the lead acetate into black. Lead, when reacts with sulfide ion, forms a PBS, black colors PPT. It gives you black colored PPT. So this is another test we are conducting out. We'll come to the chemical reaction in the next page. We have nitrite ion NO2 minus, which upon reaction with acid gives you a gas called as nitrogen dioxide, which is a brown colored gas. It's a brown colored gas which when acidified with potassium iodide solution containing starch, it converts the starch solution blue. What is it doing, by the way? Maybe with the potassium iodide, it is converting itself will be getting reduced to nitric oxide, and potassium iodide it will be converting into I2. I2 when comes in the contact with the starch solution gives a dark blue color, deep. We have another ion, acetate ion, which simply a weak acid can be formed over here using CH3COH on reaction with H. It can form you acetic acid. Acetic acid smells like vinegar and also turns the blue litmus red. So these are some sort of, we can say, basic tests we conduct. Yeah, hi Nitesh and hi Stereo Stories for you. Thank you. Thanks for your appreciations, and I am pretty much seeing the all chats. Any one of you faces any doubt, do let me know. I'll help you over here. I hope we all are clear till here, sir. This is a purely theoretical part. This can be highly boring, but I have plenty of very amazing and interesting questions with us that will definitely amuse you. So just confirm everything that we have done till here. This was the preliminary test that we were about to conduct. We just about to react the given anions with dilute H2SO4 to know what salt is there. There could be a possibility that even after passing through dilute H2SO4, no effect might be seen. We have something else for these kind of anions. We will go for some another thing for these anions. And those who haven't liked the session till now, do like the session right now ASAP. As I was talking about that, this is not gonna to happen for all of the ions. Let me star mark this part. If a lead sulfate or barium chloride kind of salts are present in the mixture, then they will react with the H2SO4. On reaction with dilute H2SO4, they will give you some lead sulfate and barium sulfate kind of precipitate. So they will produce you precipitates, and precipitates are highly tough to undergo confirmatory test or wet test. So what we should do, let us first read this entire expression. An aqueous solution of above mixture does not give a test of sulfate ion because sulfate ion is there as an insoluble ion, and it is like there in the crystal lattice of PbSO4. This insoluble substance does not give any test of the corresponding ions, not even anions in water. So to detect these ions, they have to be made soluble by preparing the soda extract. So now we have another interesting term with us called as soda extract. So we have to prepare soda extract first, then only they will give you the corresponding test. Okay, so what we'll do, soda is actually sodium carbonate we are talking about, Na2CO3. we require 1 mole of these individual salts along with 3 moles of sodium carbonate, which gives a proper reaction of PbCO3 plus Na2SO4. So guys, you can check it out, this reaction. Also, BaCl2 on reaction with BaCO3 kills you barium carbonate and NaCl. And now once we have boiled these solutions, that was already a solid initially, was not even reacting with anything. Initially only barium 2 plus Cl minus ions were available. Now once we are reacting them with Na2CO3, we have plenty of ions with us, which are barium 2 plus, carbonate ions, chloride ions. We have also sulfate ions with us, so CO3 2 minus ions. So these are the ions right now which are available in our mixture. Yes, definitely Ba2 plus will also be there, barium ions also. We have made these ions soluble in water by treating with soda extract, by making them soda extract. So now, after preparing the soda extract, it is our next task to get every single thing ready and getting them reacted for the further confirmatory test. All the anions are detected from the soda extract. All the anions are detected through the soda extract. We make them react with soda extract. We make their extract and then we react, except bicarbonate and carbonate, because the soda extract we are talking about itself contains the carbonate ion inside it, which upon further decomposition can lead you to the formation of bicarbonate also, or maybe in the presence of acidic condition it can give you bicarbonates. So there is no point of adding such kind of ions into that which already are present inside, and for whom we are gonna to conduct our test. We are not supposed to give them the extra those kind of similar ion, because it will give you no result anyhow. Now it's very useful if any water insoluble salt like barium sulfate, lead sulfate, SrSO4. I'm star marking this part, guys, because this can be asked for which of the following number of compounds or salts soda extract test is conducted. So soda extract is made for which of them, which are insoluble, which will give you the precipitate at initial, but we require them in their aqueous solution form, where we can carry out the further confirmatory test or wet test, we call it. This is how we do. So before conducting any test for the confirmatory test, especially we are talking about, before performing test of any acidic radical from soda extract, it must be neutralized by suitable acid. The anionic part of acid must be different than the radical that has to be detected. These are the two conditions, as I have already spoken about them. The very one, the soda you are using, this is not useful, and this process is not very much useful in the terms of carbonate and bicarbonate, because your soda Na2CO3 itself contains carbonate ion, which upon the influence of acid, see, before performing the test, acidic radical from the soda extract must be neutralized. So let us suppose if we are getting it reacted with the given acid H2SO4, let us suppose, and if it gets converted into HCO3 minus your soda extract itself, so this is something which is already present inside the solution, which is your carbonate and bicarbonate. We are not supposed to bring these ions into. So we are not supposed to conduct any of these performing these tests in case of these ions. Anyways, we'll come to the further clarification later. So I think now we should start. So we can make the soda extract of each and every ion. Let us just start it from carbonate. Very simple reaction, everyone. So let us suppose carbonate is given to us. We are not supposed to make it the soda. We are not supposed to make the soda extract because carbonate is already available to us. We simply make it reactive with dilute H2SO4, which makes it converted into H2 and CO2. Now this CO2 once passes through this lime water, as I was already telling you, this lime water gets converted into calcium carbonate and water. So calcium carbonate is actually white PPT in water. So this turns the lime water milky. So this is the white PPT we are talking about, turns the water milky, lime water milky. It was initially colorless or like transparent, or it was like with no color, just like water, then it gave you white color. If CO2 gas is passed in the excess of the lime water, then the milkiness produced will be disappearing soon. Why? Because calcium carbonate on reaction with CO2 and H2O gets converted into calcium bicarbonate, and bicarbonates are pretty much soluble, and there is no white PPT will be seen in the case of calcium carbonate, bicarbonate. So in the similar way, CO2, SO2 is also acidic in nature. SO2 can also turn the lime water milky, but CO2 is odorless and SO2 has a characteristic smell. Now this is something which is purely theoretical. Even I will have to check what smell does SO2 have. How does SO2 smell? Irritating odor, burnt matches. It has an irritating odor and not so pleasant odor, by the way. And yeah, definitely it's not a perfume which we are smelling, so it will happen. Next is this test. I'll come after drinking a bit of water. You just carry on, try reading this, and I'll come back and join you. Allow me just a second. Okay, 1 second is done. Allow me a minute now. Yeah, guys, so I'm back. So where were we? We till now have covered carbonate ion, right? Carbonate ion is pretty easy. Yeah. Carbonate ion on with acid produce CO2 gas. CO2 gas turns lime water milky. See how easy it is to identify carbonate ion. Problem arises from not from here. Even sulfide is highly easy. See what we'll do, the test for sulfide ion, S2 minus ion. So S2 minus will be present in aqueous solution. So let us say this is your aqueous solution. On reaction with acid, it gives you H2S gas. See, already preliminary tests have been conducted. Now we are conducting the confirmatory test. Preliminary tests were conducted how? Like sulfur H2S is a will give you a what was that? Rotten egg kind of smell, some irritating smell. So when it is get reacted with some compound of lead, let's say lead acetate, it gives you lead acetate as a black precipitate. So this is how you can make your notes, everyone. Just try to pick each and every individual anion, write Cl minus. Here you write, so you can make a list, and just add the category that, like right now first A we are dealing with. Make a column by the name of pre-test or dry test, another column confirmatory test or wet test, and write at once only that what we are doing. So CO2 gives you brisk effervescence as its preliminary test, and as a turning lime water milky is the confirmatory test. Along with that, if you keep on passing it later on, then it will make that transparent also by the formation of calcium bicarbonate. That is the confirmatory test. Next test of sulfide ion. Okay, so we'll conduct so many tests right now. Okay, we initially had one test in which we are converting our sulfide ion into lead as sulfide, which was black colored. One confirmatory test is here. Another confirmatory test could be, this is A, this is B. Another test could be, we have sulfide ion with us. So what we'll do, we'll make this sulfide ions with us getting reacted with sodium nitroprusside. Sodium nitroprusside is a compound that we all must remember about, where we see iron is in +2 in everywhere. I can see iron over here is in +2 oxidation state. And let me check if I'm right here. This is +1, +3. This is fine. Okay, so see, nitronium ion is here, NO plus is there as a ligand in this compound, sodium nitroprusside. This sodium nitroprusside, whenever it is added with sulfide ion, this NO gets converted to NOS. So this NOS has a minus charge here. So it's a negatively charged species ligand, and it forms a complex, and then a purple color is appeared. Initially it was a colorless, now a purple color is showing you the presence of sulfur. Now you can balance the charges accordingly. No need to learn anything. Okay, giving you an idea about the same. See, we had sodium over here, Na plus. We have this iron. Iron is in +2 oxidation state. We have cyanide ions in the state of -1. We have nitrosyl ion as a +1. So it's a total charge is 2 minus 5 plus 1 is your -2. So -2, just cross multiply with the charges, you get Na2 FeCN5 and no. See, talking about the another one, the purple colored complex so formed with NOS, this anion. So how does it work? By the way, we had Na positive as a charge over here. We had another complex with cyanide ion R5, and along with 5 cyanide ions we have NOS also. So let me just check it, everyone. This is -1, this is -1 and 5, -5, -6, and this is +2, so 4. So this is overall -4 charge. After cross multiplying with the charges, it will become Na4 FeCN6 5, sorry, and NOS. Coming to the next anion, we have nitrite with us, everyone. Make sure that we are going through each and every anion very carefully, because right after this, we will be having a set of questions with us. And only those people will be pretty much able to solve the question, who have covered this part easily and carefully and have noted down the properties carefully. Anyways, we have nitrite ion. What does nitrite ion do? Another important and very easy test. Nitrite ion on reaction with acid produces nitrous acid, HNO2. Nitrous acid itself has so many uses, and nitrous acid is always a freshly prepared acid. If you leave it like this, even at room temperature, it gets disproportionate into nitric acid. Nitric acid and nitric oxide. +4 is the oxidation state here, not +4. X -3 +1 +3, converting into +5 and +2. So it's a disproportionation reaction, where now this nitrogen oxide or the nitric oxide, the gas over here, it is now further oxidized, and upon oxidation it gives you brown color gas, confirming the presence of nitrogen dioxide. This is the one test which we are doing, one test. Another test could be, make your nitrite ion getting reacted with acetic acid, which gives you acetate ion, and HNO2, which is another the same nitrous acid. This nitrous acid on reaction with potassium iodide, this reaction with potassium iodide produces with acetic acid produces the salt of acetic acid, along with, importantly, nitric oxide. Okay, so this is from positive 4, this is getting reduced to positive 2. On the same angle, this -1 charge of iodide is converted to 0, yani this is oxidized, iodine is oxidized, nitrogen or HNO2 is reduced. This iodine, as I told you, makes a complex compound with starch and giving you a dark deep blue color. So there we have a blue complex of iodine and starch. Starch solution, iodine in starch solution produces blue colored complex and gives you blue color. Hopefully this is also clear to all of us, and even if it is not, just read it out carefully as I told you initially. And all of my notes are self-explanatory notes. You just need to read it out once. Believe me, you will be getting to the proper explanation by even by your own if you get it, like if you read it carefully. So that is how it look like. Control negative test, starch positive test. No idea. Control what? It's simply it is like another test could be, another test I am doing with so this is a one test which we are doing. Okay, the other test could be reaction of nitrous acid, like the one which we are getting right after the reaction of nitrite ion with nitrite ion on reaction with acid gives you nitrous acid. Nitrous acid on reaction with this organic compound, especially the one which contains amine group over here or aromatic amine is there. This could be, this is your amino acetate, but this could be aniline also in the case of aniline. This compound gets converted. This is what we study in our amines chapter. So this compound on reaction with HNO2 gives you a compound like this, which is a containing an azo group. Azo group is like N double bond N kind of. This group then reacts with this compound, or this is a kind of like aniline kind of compound, which is a similar to aniline compound, and we have called this compound as 1-naphthylamine. So this is 1-naphthylamine. Naphthylamine on reaction with this produces a red colors dye. This red colors dye is a confirmatory test that we have. We initially had a nitrite ion with us. That is how we do. So the test solution should be very dilute. The test solution which you are doing should be very diluted. In concentrated solution, the reaction does not proceeds beyond, I don't know what is it written there. The reaction doesn't proceed beyond diazotization. You cannot take this reaction beyond diazotization. It stuck at the diazotization part. So this kind of compound is observed, this red color dye, this red azo dye. This is your red azo dye. We have acetate ion in the very next. The fourth anion is acetate anion. What we do with acetate anion? See, acetate anion on reaction with acidic medium or dilute H2SO4, as we are doing it for the all first A anions test, it gets converted into acetic acid. And acetic acid upon reaction with ethanol, see, ethanol. So it gives you a reaction. See, this is the chemical reaction. CH3COH plus C2H5OH under acidic conditions goes for esterification, forming CH3COO C2H5 plus H2O. Now it smells fruity. It smells fruity. It smells good. So this is the preliminary test, because this fruity smell and all, this is what we do for the preliminary only. We had another test, that is 0.1 gram of salt we are taking, adding 1 to 2 milliliter of distilled water and shaking it well, filter it necessary and add 1,2 neutral ferric chloride solution to filter it. Deep colored appears when disappear or boiling. Red brown PPT is formed. So what is this, by the way? Preparation of neutral FeCl3, dilute and newer solution is used to react with a ferric chloride solution drop by drop. Shaking until a small but permanently precipitate of ferric hydroxide is obtained. Filter the precipitate and use the This is the method of preparation of neutral ferric chloride. Neutral ferric chloride, no acidic radical, no protons inside. Next, now conformity test of the acetate ion is ongoing. The one test we already have confirmed, that was for the acetic acid. We made it acetic acid. It on reaction with alcohol gives you the fruity smell of the ester. The another test that we were doing was the reaction with ferric chloride. And now we'll see what reaction happens here. That will be coming over here in this part. Here is the reaction, everyone. Check it out. The reaction is over here. So this was the first test we have conducted. The first part. Here is the first part that we conducted. Here is the second part. In second part, we have acetate ion with us on reaction with FeCl3, which is containing the ferric ion. It makes a complex. It makes a complex of this Fe3OH whole twice and acetate ions are 6 acetate ions are needed there. So this complex upon reaction with water just simply gives you OH whole twice and acetate ions with that, and 3 acetic acids are getting away. This is iron 3 dihydroxyacetate. It's a brown red PPT. I will give you a suggestion. Even as a teacher, I do not remember the formula of these compound. So that is why just try making short notes and take the idea only that what color will be preparing. This is the particular compound and this is the PPT which is giving you the final confirmation. Not even the ethyl fruity, like this fruity order is also a conformity test, one of the conformity tests coming out of the smell, but a chemical reaction with the change in in the way of precipitation formed, color change will be observed. That is a conformity test we will observe for the case of acetate ion. Brown red PPT will be observed. This is how it will look like rust. So now where were we? We have till here covered all the what we have covered till here. Seriously yaar, what is happening wrong with here yaar? Yeah, so the first A part is covered till here. These ions we were earlier seeing, like carbonate, bicarbonate, both of them have the same way, and sulfide, then sulfide and bisulfide even with the same thing, and we had acetate right now. So now we are coming to the second A category. Second A category where fluoride, chloride, bromide, iodide will be tested later with nitrate ion. So let me take you to the next part of this chapter. Category second A starts from here. Second A, preliminary test first will do. We'll do the confirmatory test later. So initially in the preliminary test, the preliminary test is conducted where HCl is produced on reaction with concentrated acid, and this chloride minus give you HCl. HCl has a colorless gas with a pungent smell. This pungent smell gives a dense white fume on reaction with rod dipped in ammonium hydroxide. So guys, what is happening here? Ammonia gas on reaction with HCl gives a NH4Cl compound, which is also a white colored solid, and white color fumes are formed on reaction with HCl and NH3. That NH4Cl is basically observed on this reaction as a confirmatory test. The another is brownish vapor, which will be appeared when concentrated acid reacts with bromine, oxidizing it to give you the Br2 vapor. Concentrated H2SO4 is also working as an oxidizing agent, so oxidizes Br minus vapors to Br2. So reddish brown vapor with a pungent odor is evolved. The intensity of reddish brown gas increases on heating the reaction mixture after adding the MnO2 to the reaction mixture. The solution also acquires the red color. So the red color liquid that you are obtaining, and even if you add their solid MnO2, it also provides the reaction, and the solution has a dark red color. The color intensity is increased. This is the preliminary test of Br2, or sorry, Br minus. Iodine minus produces I2. I2 vapors whenever it is passed through the starch. Always remember this point in your minds. Iodine makes a complex with starch which is extremely deep blue in color. So that is a confirmatory test for iodide. That's a confirmatory test of iodide. So okay, next. So violet vapors, which turns the starch paper blue, and a layer of violet sublimate is formed on the sides of the tube. Okay, now the fumes become dense on adding MnO2 to the solution mixture. So guys, MnO2, once initially it was added to the mixture of the Br2, it was converting it into the Br2 vapors were converting into a dark red color. Now it's the blue color which is appeared because of the iodine and starch complex. It will be densed. It will give you another dense color. Next is nitrate ion. We have nitrate ion on reaction with concentrated acid gives you nitrogen dioxide as a gas, NO2. NO2 gas evolve which become dense upon heating. So this gas is a brown color gas, and this color also upon heating becomes even dense. The reaction mixture after adding copper turnings and the solution acquires a blue color. So if we add copper turnings in it, some fillings of copper, this changes itself into blue color. Next is the confirmatory test. So there is one test which we are doing, that initially HCl is produced by reacting with concentrated acid. Now on reaction with NH3, it gives you white fumes of NH4Cl. One test. Next is, if we are reacting, if we are undergoing any if a salt gives you effervescence on heating with concentrated H2SO4 and MnO2, a light greenish yellow pungent gas is evolved, and this indicates the presence of Cl- ion. So on reaction with MnO2, manganese dioxide, which is also an oxidizing agent, with chloride itself from -1 gets converted into Cl2 gas, and manganese from +4 get converted to +2. So that is how this reaction occur. But most importantly, a greenish yellow gas with pungent odor is appearing there indicates the presence of chloride ion. Hopefully this part is pretty much clear to all of us. NCERT का playlist नहीं है. No, we do not teach only NCERT. We teach every JEE Main and Advanced. We deal it with. Along with that, we have playlists for organic chemistry specifically. We have chemistry of 11th and 12th as playlist, and the rest everything you can check on our live segment. Just go to our channel YouTube Unacademy JEE English and just search the playlist. Not playlist, check for the live segment. Scroll the videos and you will find mine. All the chapters probably from physical and organic are covered. Only organic chemistry few chapters are left from 12th standard. So today I was expecting a better crowd. No idea why people haven't come. Students were supposed to be here because this is an important topic and we are bringing this on your demand only. You people have asked. Anyways, now we have confirmatory test for Cl- continued with another test. Another test could be react with AgNO3. It will give you NaCl plus AgCl, which is a white PPT. Another confirmatory test. This sound reaction with ammonia or NH4OH makes a compound which is a coordination compound and which is soluble. So again, diamine silver first chloride is actually soluble. Let me write aqueous. But this was earlier a solid and it was working as a white PPT. So this is the difference. That is how we can predict the presence of Cl- ion. Another test called as chromyl chloride test, which is also conducted for chlorine only, chlorides only. Chromyl chloride test you people have already covered in organic chemistry. Very important test. We call it chromyl chloride test. One of the very important tests. Maybe in like a where did you color? Oh, okay. I remember. In the reactions of K2Cr2O7 we have studied it. In DNF block you studied it. So what we are giving a reaction like we had NaCl or chloride ion present with us. That upon reaction with potassium dichromate in acidic conditions gives you CrO to Cl2 called as chromyl chloride. This chromyl chloride in basic conditions give you sodium chromate NaCr Na2CrO4, which upon reaction with chromyl chloride is also a yellowish kind of compound. It's a reddish brown, dark red kind of liquid that we ate. This chromyl chloride, which upon further reaction with the basic medium produces sodium chromate, and that sodium chromate on reaction with lead acetate produces lead chromate and a yellow color PPT. This yellow PPT is signifying that we have a presence of chloride ion in the original solution. Yeah, guys, now I'm back. We have confirmatory test. Next test for chloride ion. We were initially conducting chromyl chloride test, which was a confirmatory test for the a reddish brown basically liquid is formed here, which on reaction with NaOH is being converted to sodium chromate. Then upon reaction with sodium chromate on reaction with lead gives you lead chromate as a PPT, which is yellow color PPT, confirming the presence of Cl minus in the initial ion. Confirm minus is the initial ion. It's a big fan एक doubt था. Okay, please ask me. You can post your doubt same where I can read your doubt and can give you the answer. So right after that we have another test here with Cl minus ion, and the same thing which we are doing it, this chromate ion test that we are converting into right after the chromyl chloride test on reaction with NaOH gives you sodium chromate Na2CrO4. This Cr2O4 reacts with Cr24 minus Cr2O4 sorry CrO4 2 minus ion. Where is it? Where is it? CrO4, let CrO4 2 minus ion, this chromate ion test reacts with hydrogen peroxide producing a chromium pentoxide with water, and this chromium pentoxide which we have received, which dissolves in amyl alcohol to give a blue color. So this when reacted with amyl alcohol gives you the blue color. Produces blue color. There we go. So right after finishing chloride ion, next we have bromide ion with us. The most easier, most common test for all of these ions is this. A most common test for all is passing these Cl minus, Br minus, I minus. Let us take even F minus. So this is F minus, Cl minus, Br minus, I minus. These all ions on reaction with aqueous AgNO3, on AgNO3 reaction with AgNO3 produce silver fluoride, which is not even solid. This is soluble in water. We have AgCl as a white precipitate, AgBr solid silver bromide as some pale yellow PPT, and then AgI is a yellow PPT. That's how we carry this test. Next is confirmatory test of bromide. Another test of bromide ion is a displacement test, in which what we do, we will use another halogen, and which more reactive halogen displaces this and forming Br2. Br2 we all know it's a red color liquid. So let us just first read it, because this test will be continued for upcoming halogens also, because when we go down the group, the reactivity of halogen decreases. The upper positioned halogen can displace any of the downstand halogen from its compound if you go down the group. So anyways, neutralize 1 milliliter of sodium carbonate extract with hydrogen chloride, or take the water extract. Okay, so you will make a compound of aqueous NaCl there, and add 1 milliliter of carbon tetrachloride there, or chloroform or CHCl3 can also be taken. So now add an excess of the chlorine, water, drop by drop, and shake the test tube. A brown coloration in the organic layer confirmation the presence of the bromide ion. So that's how we do. We already had NaBr with us, which upon reaction with chlorine produces NaCl plus Br2. So now this NaCl is dissolved in water, Br2 is dissolved in CCl4. In CCl4, it gives you this brown color, and the one which is in water itself will be giving you some yellowish color like that. Then another reaction I told you that the best reaction to go for the halide ions is aqueous AgNO3, gives you AgBr, a pale yellow, a light yellow kind of precipitate. We have another confirmatory test of iodide. One of the tests has been already conducted, that you can get AgI. You can go for the reaction of I minus with Ag, which can produce AgI, like aqueous AgNO3 plus iodide ion can give you AgI precipitate, which is a dark yellow PPT. Earlier in AgBr we are getting pale yellow. Earlier in AgCl we are getting white PPT. AgF itself is soluble in water. So that is how we get the differences between different ions of halide ions from each other. Okay. So this reaction is basically sodium iodide on reaction with H2SO4 gives you sodium Na2SO4. NaI with H2SO4 gives you Na2SO4, NSO2 and I2. This I2 on reaction with starch solution gives you blue color. If you add this solution MnO2, it will give you deep blue color. That is also confirms the presence of I2. Another reaction could be NaI with reaction with H2SO4 gives you HI. HI on reaction with H2SO4 further gives you I2 on oxidation. I2 on oxidation. Then what is the wrong with here? H2SO4 gives you I2 plus this. What is happening? On adding MnO2 to the reaction mixture, the violet vapor become dense. That is what I am telling you, that NaI plus MnO2 plus H2SO4 gives you I2 plus MnSO4 plus Na2SO4 plus H2O. Even dense violet vapor become dense. So I minus on MnO2 gives you I2. So guys, look at this. We have different colors of iodine in different phases. That if we dissolve iodine in the distilled water, this is how its appearance look like. In water, we have a bit kind of like yellowish, dirty yellowish color. In ethanol, it gives you this reddish brick red kind of color. In what is it? In KOH, in what is this compound by the way? In Ki, potassium iodide solution, we are having a and then we have hexane. We have I2 in hexane. Then iodide can also undergo this reaction with Cl2, where NaCl will be formed along with I2. The same reaction we can go for. We are taking 1 milliliter of salt solution neutralized with HCl, then adding 1 ml of chloroform and in carbon tetrachloride and or CCl2, or but this is something that is different from the water. It is a non-polar solvent we are taking. This non-polar solvent dissolves iodine inside it, giving the violet kind of color, and the remaining water itself contains NaCl with some kind of yellowish color. So this color appears, a violet color appears in the organic layer. This is what this test is all about. Exactly the same which we did for the bromine also. Another confirmatory test is very easy. Reaction with silver nitrate can give you AgI, a silver iodide solution, which is a yellow color PPT along with NaNO3. We have till here finished all the halides. all the initial first A category. Now this is your second A category, which are the ions which will give you, what does it produce? With concentrated acid, they gives you volatile product. Next is the confirmatory test of nitrate ion. Nitrite ion is already covered, that used to give HNO2 acid, nitrous acid, in presence of dilute acid. Nitrous acid had its own chemical reactions, like it itself gets disproportionated into HNO3 and NO, and NO nitric oxide upon reaction with nitric oxide on reaction with oxygen used to give us the NO2 brown color gas. Next is nitrate ion test. Okay, we'll go for nitrate ion test. So on heating the salt with concentrated H2SO4, when we heat the salt with concentrated H2SO4, the light brown fumes are evolved, which are NO2, which will be definitely containing NO2. And for this given salt with few copper turnings or chips, like we are putting some of the copper metal there in the form of its chips or some kind of like copper turnings. It's some sort of like granules which you are putting, kind of like. Then and with H2SO4, evolution of excess of brown fumes indicate the presence of the nitrate ion. So let us check what reaction we are talking here about. So sodium nitrate with nitrate solution is now reacted with concentrated H2SO4, which will give you NHSO4 and HNO3 acid. Nitric acid itself gets dissociated into NO2 and O2 plus H2O. This so formed NaNO3, another reaction is here, in which H2SO4 plus Cu, it gives you copper sulfate of blue color and rest of these compound. Now that nitric oxide on reaction with NO2 gives you the brown fumes of NO2. So learn it everyone, just take this idea from where we have to start it with till where we have to reach it with. We had initially presence of nitrate ion. In presence of acid, it gets converted to nitric acid, that itself get dissociated into NO2, O2 and H2O. NO2 is a brown colored gas, gives you the conformation of nitric acid. Another could be you can react it with H2SO4 and copper, where copper sulfate in blue solution will be appearing. Then nitric oxide, once it is oxidized with the oxygen, it gives you brown color fumes which are coming out of the solution. This indicates the presence of the nitrate ion. This is the procedure given here. This is the procedure which we can read it out. Or there is one more thing which we can do. Like right after the reaction of NaNO3 with H2SO4, we got HNO3, which is nitric acid. Nitric acid reacts with iron sulfate Fe2 plus in acidic condition and oxidizes it. You can check it out. Iron in Fe2 plus gets converted to iron 3 plus, and itself gets reduced to, from positive 5 state it goes to positive 2 oxidation state, which is nitric oxide. Now this nitric oxide reacts with iron sulfate, giving a brown color. This is just like the brown ring test we used to carry out, exactly like that only. So this reacts with this and producing a brown colored PPT called as nitrosoferrous sulfate. We have also another ion with a sulfate ion. So we till here have completed the all first A and second A. Now we are into B category, where no volatile product will be formed. We have only precipitates with us either, or the reactions of redox we will be follow. So just take an idea here. 1 milliliter of water extract. Water extract is nothing, guys, just the solution in water. The salt you are having, just dissolving in it water, that is called as the water extract. Okay. So next is the test of sulfate ion. A very common test is reacting it with the barium chloride. Barium sulfate is a white PPT. The very common test, that is what we carry out, very common reaction we carry out, everyone. That take this barium chloride solution, get it reacted no problem. Let me write the reactions for you. So allow me a sec, everyone, allow me a sec. हेलो, हाँ मेरी आवाज आ रही है? मैं अभी तो ऑफिस Hopefully you all have read it till here. So didn't have the lunch and I was feeling hungry a bit. Brought up with some cookies and milk. Yeah, guys, let us continue from here. So first of all, let us finish all our anions and then we'll go to cations. So meanwhile, we can have a short break with us. Okay. Yeah. So we have sulfate ion here. So sulfate ion, one of the tests is very easy, that if you react this sulfate ions with barium chloride, barium sulfate is a white PPT. We all have heard about it. Another test could be lead sulfate is also a white PPT that can be produced by reacting lead acetate and sodium sulfate. So let us read this entire para here. Take 1 ml of water extract, which is the water solution of the salt. Add, or you can take the sodium carbonate, and after acidifying, we can also take the sodium carbonate solution where sulfate ion will be produced. So there, what we have to do, or we dilute HCl, okay, let it go. We have to react it with barium chloride solution. The white precipitate of BaSO4 will be formed, and which is insoluble in concentrated HCl. Concentrated HNO3 is obtained. So white PPT is obtained. Then acidify the solution or sodium carbonate solution extract with acetic acid and lead. This is the same thing that is written here. Yeah, so boring. Yeah. Move forward, man. Till here we have finished all the kind of anions we had. We'll go for some quizzes. We'll have some questions with us. Right after the questions, we'll go for the another segment of cations. Okay. The carbonate ion of which of the following is insoluble in water? Which of the following cation has carbonates as insoluble in water? What is your answer? I know that lime water turns milky, you remember everyone? So what used to form there? Lime water, whenever it turns milky, this forms calcium carbonate there, and calcium carbonate is insoluble in water. Right? Rest all of them other have soluble salts. Next question. A colorless salt A reacts with H2SO4 or CH3COH plus Ki and gives a blue color solution with starch. What it can be? Give me the answer. So it is a colorless salt we have. Colorless salts is actually, everyone is the colorless salt here. I think it could be, see, first as K2SO3 doesn't make any sense because the reaction is pretty simple. Iodine is gonna to be oxidized to I2. That only produces blue color with starch. So reaction somewhere I'm finding it should be like this. NO2 minus with, okay, let me write the whole reaction. This reaction with Ki gives a product of ammonium acetate and this is -1. This is +3 here. So it will give you nitric oxide and plus I2 we have. This I2 with starch has a blue complex. Simply learn it. Now we have to check what is the, okay, this is the correct answer. This is the correct answer. Next question. A mixture when rubbed with dilute acid smells like vinegar. So which basically ion we have studied smells like vinegar on reaction with acid? I remember that acetate ion on reaction with acid gives you acetic acid, a weak acid. The reaction is also very spontaneous, nearly with all acids. D should be the correct answer. And I can write the reaction also. CH3CO minus ions with HCl, let's say dilute, produces CH3, COH, acetic acid along with NaCl. So this is actually, this smells like vinegar. Moving forward to another question. Try this question, everyone. So which of the following combines with iron 2 plus to form a brown complex? This is your brown complex. Oh yeah, what is it? Nitrogen dioxide. Okay, I'm confirming one thing. Where were we getting that brown complex? We have so many things here, that's why it's better that we confirm from somewhere. The previously I got stuck here actually. Let me just find the correct answer, everyone. I'm just rechecking where was that iron complex, and because I remember that was nitric oxide there. Where is it, yaar? Somebody has deleted it or what? Huh? No idea. Okay, there we had it. See, iron sulfate with nitric oxide used to give us FeNOSO4. So nitrous, this is nitrosoferrous sulfate we studied, and this was brown in color. So I'm absolutely right here. I don't know how come they are showing it. This NO2 over there. NO2 itself is brown in color. Nitrogen dioxide gas itself is brown in color, everyone. So anyways, let us see. So there we were. So the answer I have submitted here is this one, which was a brown nitrosoferrous sulfate, we used to call it. Maybe they wanted to write it NO and mistakenly they have written it like that. Anyways, we'll come to next question. Try this question, everyone, by your own end. Mixture of solid NaCl and solid K2Cr2O7 is heated. How deep red vapor are obtained? Chromyl chloride. Right? We know this reaction. CrO2, Cl2. These red vapors are of CrO2, Cl2. AgCl dissolves in ammonia solution giving what? So AgCl goes in ammonium hydroxide or ammonia solution producing AgNH3 whole twice Cl complex, which is even solution, which is even soluble in water. So D should be the correct answer. Right? Take this thing as an example. An aqueous solution, cation will be a complex like this and an anion will be Cl minus. Next question we have. When chlorine Cl2 water in excess is added to a salt solution containing chloroform layer separates the pale yellow. The salt contains what? Added to chloroform. Okay, to which ion does it replace? So it's very simple reaction, everyone. Try to do this question. Okay, I'll explain this. And the chloroform layer turns pale yellow. Anyways, let me guess this reaction and let me take you to the final outcome of this reaction. What we have with us, when chlorine water is in excess and it is added to a solution containing chloroform along with some ion only, chloroform layer turns this, the salt contains what? So guys, the reaction may occur into two ways, like NaBr is there and on reaction with chlorine minus, it may convert it into, let's say this is 2 2, so 2 NaCl will be there and Br2 will be appeared. Another similar reaction is 2 NaI on reaction with 2 Cl minus gives you 2 NaCl and I2. So I2 has a purplish color, this has a brown color. No idea, yaar. Okay, I minus is the correct answer. Anyways, I would like to take you to this para only, where we can understand what was actually happening there. We had two things here with us. The first one was the bromide ion. Check it out, everyone. Bromide ion. So NaBr on reaction with Cl2 gives NaCl plus Br2. So this is your pale yellow color. This is also yellow color here. Then this is a brown coloration in organic layer, confirms. Okay, this is brown color in organic layer. So this is actually the one. Okay, let me check what color does chloroform has. It's clear, colorless. So guys, let us just think about it that we are adding chloroform here. So this is actually, this mixture is actually CCl4 plus Br2, because CCl4 will be easily dissolving Br2 or chloroform, let it be. And this actually is a brown color. We see it's a brown color. And this another half could be your probably your chlorine water which we are pouring there. This probably your chlorine water. Okay, this is how this reaction going on. The same reaction also goes on with iodide when this reaction is happening. So here what happens, we have two layers. The one is organic compound, let's say CHCl3 along with iodine. Iodine will be dissolved in organic solvent. And then we have another layer. Another layer is actually of chlorine water. So this chlorine water will be similarly that yellowish color will be there, vivid yellow. And this color will be violet. This is the organic color and this is violet. Now actually my question is, coming to this question, we had two things here with us, and one of them could be bromine, another one could be iodine. Or yaar, where is that question here? This is the question. And it says that chloroform layer turns pale yellow. So pale yellow, I don't know why is it showing with iodine gives violet. So this Br2 in organic layer brown, and this I2 in its CHCl3 chloroform, it shows you violet. No idea, I am leaving this question up to you. Chlorine water is in excess to be added on a salt solution. Anyways, you find out by your own. I didn't find that question correct. We have next question, everyone, with us. Nitrate ion is one, confirmed by its brown ring test. The brown color of the ring is due to the formation of, I remember this was your, we were about to react iron sulfate with nitric oxide. That was actually, nitric oxide came from the nitrate ion only. We were studying that HNO3 upon simply gets converted into, on heating, maybe HNO2 and nitric oxide and water, like that. So more or less this is, this nitric oxide on reaction with iron sulfate gives you Fe and no SO4. So like this is a complex somewhere, and this is nitrosoferrous sulfate, which is brown. I think B should be the correct answer. So that was it up to the analysis of anions we have studied till now. All the anions we have completed till now. Right after anions we have cations to cover. All the cations we need to cover. So anyways, we'll start one by one. We have qualitative analysis of cations. So let us just first finish all the preliminary tests and with the general tests we conduct. Then right after that we'll go for confirmatory test of the anions and their grouping. How are they divided into separate groups? The very first thing, that is the parts of a flame. I must tell you why is it so, because parts of a flame is highly useful, especially when we are going for the analysis of cations. So guys, this is actually a Bunsen burner. We have a Bunsen burner. The flame so produced by the Bunsen burner has a few types here. This part of the flame is called as no combustion flame, no combustion zone, because here no oxygen is available for the combustion. Because of the lack of oxygen or the absence of oxygen, there is no as such combustion takes place in this part, right? Right after that we have some middle part here, kind of like this part, and this part has lesser oxygen, more hydrocarbon. So this is where the hydrocarbon is coming from. This is where the hydrocarbon, or we must call it as a fuel, is coming from. Fuel is majority over here. No combustion zone, only fuel is there, no oxygen. No combustion zone, no oxygen. Actually we have, why are we calling it no combustion? Because we have no oxygen available. So no combustion is here. Sometimes we see that even in a like candle's flame, we move our finger through it and we don't feel any heat, because we usually pass it through that part which is where only combustible particles are there, but there is no oxygen enough to burn them. The next one is this part called as the reducing flame. Why are we calling it as a reducing flame? I'll tell you. Because reducing flame is actually containing more hydrocarbon or fuel and less oxygen to burn. So that is why this is called as, because of hydrocarbon it can reduce down anything. And at last, at the end of this, you might be seeing this part, or this corner part, or this edgy part is called as oxidizing flame. This is oxidizing flame because this is having less hydrocarbons here, and we have more oxygen here. So please follow this thing, and using this only we'll continue and we'll reach to some of the very good outcomes, because cations even under or a particular salt or even on dry heating can give you different coloration in its reducing and its oxidizing flames. So this is a burner, Bunsen burner we call it, Bunsen burner. Now we'll conduct the dry test for cation, okay? Dry test. What is the meaning of dry test? Okay, simply heating them. Don't do anything, just heat them. Don't even heat them, just check them. Just look at them like that, okay? I don't know what are they doing here. Let me check. Okay, now simple color test we are doing. The very first thing is called as color test, means just observe the color. Observe the color of the salt carefully, which may provide you a useful information about what kind of salt are we given up with. Take this example. If there is a light green or yellow or brown, then there is a possibility of iron +2 and +3. Blue colored because of copper 2+. Bright green color could be because of nickel 2+. If blue, red, violet, pink kind of color is there, it because of the cobalt 2 positive ion. Light pink color is because of the manganese 2 positive ion. This is something that their usual salts contain the color of. Let's suppose we are talking about the ferrous chloride or ferric chloride or like ferrous sulfate. The color usually comes yellow, brown, green kinda. Then copper sulfate in its hydrated state, if it is there, it shows you bluish color. The same with manganese, shows you light pink. So this is giving us an idea, a useful information that what salt should we go for the confirmatory test. This is giving an idea. So one of the preliminary test, this preliminary test contains color test. Number 2 is called as dry test. What is the meaning of dry test here? What is dry test? So guys, in dry test, what we do, dry heating test, we are just heating the given thing and simply heat it, that's it. So initially copper 2 positive, hydrated state, it was blue in color. All the water of crystallization are now removed, it gives you white color. Iron we call it what we call it, that was blue vitriol. This is called as green vitriol. Green vitriol iron sulfate is in actually greenish color in its hydrated state. Once after losing the water crystallization becomes white or yellow. Zinc was initially white and then converts to yellow. Pink color has gone to blue. These are the preliminary tests which we are conducting for the cations. So till now we have not segregated, bifurcated or divided or classified our cations into various categories. So just simply based upon basic things, their color, their like on heating what color they produce and simple things, we are identifying their which cation we are given up. We are simply identifying it. The third is the flame test. Flame test means now we are about to burn it. And where are we going to burn it? That is a question. We all heated it already. Now what flame do they produce in Bunsen burner? We heat it up with the though first of all there is some procedure which is required. Just read out the procedure once, that the chlorides of several metal impart characteristic color to their flame because they are volatile in a non-luminous flame. Non-luminous flame is which one? Luminous, non-luminous here, more bright. This is the end flame. Non-luminous flame is actually non-luminous flame is your oxidizing flame. So because more hydrocarbon is there, it is colored. I forgot to write some more points here. Let me write. Reducing flame is luminous, means with more color, and this is non-luminous flame, luminous versus non-luminous. So we have now do one thing, make a tiny loop of platinum wire, and to clean this loop we dip it into hydrochloric acid and hold it in a non-luminous flame. So we are just burning. What we are doing is, let's suppose if there is any of the volatile impurity, so upon reaction with acid and then heating it, this may can be eliminated out, can be leaving as a volatile product or as a gas can be left out. Then we have repeat the step 2 and until the no color appears to the flame, because until then so many things will be there which are present over there in the as an impurity. We have to make them reactive with HCl solution and then concentrated HCl solution, and then their oxidized volatile product will be eliminated out. Then you got to put 2 to 3 drops of concentrated hydrochloric acid on watch glass, make a paste of this small quantity of salt inside it. So whatever the cation is there, so let us suppose if any anion is there as a remaining anion, so that will be evaporated out kind of in the form of volatile product, and the remaining cation now is left upon the loop. Now dip the clean loop of the platinum wire in this paste which we have made using the concentrated H2SO4, sorry HCl, along with the cation, and non-luminous form oxidizing flame we have to heat it into. And now you got to observe the color of the flame first with our naked eyes and then bring the blue glass to identify the metal ion with help of table 7.8. So guys, just check it out, the next step. So what is the meaning of this blue glass? Blue glass removes the unwanted yellow light coming out of the flame, and it only shows you the color you want to observe, which is a characteristic, which will create a characteristic difference between two of the different ions. Otherwise the same yellowish color will be visible to you. So first you need to check it through your naked eyes, and then you have to bring your glass, the special glass of Tony Stark you have to bring in. This is blue glass. Now let me check it. So we are now color of the flame is observed by the naked eyes. So green color with blue center comes when we have copper 2 positive ion, and the same color is observed even without glass, with and without glass. Okay. Crimson red color is seen for strontium 2 positive, and it shows us purple color when we see it through the blue glass. Barium 2 positive has a apple green color that shows bluish green. This is something you need to learn. I'm star marking it. Please learn it. This is the part where we earlier used to study in S block, the flame tests and flame colors. But since this S block has been eliminated out of our JEE Main syllabus, now it has become highly important for us to study these ions, and not just these ions. These are very important ions that are characterized by their flames, with their flame color. So they take calcium, shows you brick red color, but brick red color on wearing a blue glass will give you the green color. Now we have another dry test. Okay, no. This is the mechanism or the procedure which is being given. We take put platinum wire. Platinum wire is expensive. Don't conduct these tests at your home. You take a platinum wire, you just make a coil using a pencil. So now this dipping into the paste of concentrated HCl solution, then heating them until it shows no color, then dipping it into the concentrated solution plus salt solution. So basically a salt solution contains cation and anion in it. So whatever the anionic part is there as the belonging to first and second A category, that will be eliminated out in the form of gas. The only remaining part will be the cationic part. Then cation will give you some sort of color in the flame, and that color will be the characteristic color that can be checked. Fourth preliminary test out of these three, right after that we have fourth preliminary test where we are not doing the confirmatory test, we are just having the preliminary test now, called as borax bead test, one of the very important tests we conduct. This test is employed only for the colored salts, and because borax reacts with the metal to form the metal borates or metals, metals which have characteristic colors. Okay, so to perform this test we are not supposed to learn this thing, let it be. I'll give you the simple idea. So guys, what we do, we take borax first. This is called as borax. Borax upon heating produces Na2B4O7 and 10 water molecules are removed. This is called as sodium borate. Sodium borate on reaction, on further heating, produces sodium metaborate. NaBO2 is the metaborate ion is BO2 minus, and boric anhydride. So this is actually sodium metaborate and boric hydride is actually called as the borax bead. The mixture of these two is actually produces glassy beads. Glassy beads, spherical glassy beads are seen, which on reaction with individual cation, let's suppose copper, produces respective their ions called as cupric metaborate, which is blue green in color in its oxidizing flame. Non-luminous means oxidizing flame. On burning in oxidizing flame, it shows us a blue green color. The similar thing can be observed anywhere, making the blue CuBO2 whole twice is reduced to colorless cuprous metaborate as follows. If you react CuBO2 whole twice with NaBO2 and carbon, we are reducing it, gets converted to CuBO2. So they both have different color. Anyways, directly learn the color. Where are the color? These are the color. I'm star marking it. Learn it ASAP right now. We don't have any tomorrow now. We all have to learn these color right now, immediately. Highly important for us. That Cu2 plus in cold means in the flame, in cold means out of the flame, in hot means in the flame, in cold means out of the flame, in hot means in the flame. Here we have non-luminous flame, means we are oxidizing flame using, luminous flame which we are reducing flame we are using, in between is the reducing, out of this will be oxidizing. So why are we using the multiple coloration over here? In order to give you the exact differences between the ions. Sometimes some ion may undergo tie, they might be having same colors in the oxidizing flame. Okay, then go for the reducing flame, or let's say in and or out you can go. But again, the important part is that even if we are using reducing and oxidizing flame, there are 4 probabilities which we are getting, 4 possibilities, and 2 ions can have even 3 similarities, but 4th will be different to distinguish between these 2. So that is how we are having multiple possibilities and observations with us. So Cu2 plus has, we have to study only in this blue color. If you heat there and then make it out of it, and green color in keep on heating it, then reddish brown color if you remove it out, nickel 2 plus, if you keep on burning it, it shows you violet color. light violet if you keep it out of the flame after burning, or light violet if you keep on burning it, yellow color and yellowish brown color for iron. Learn it. 4 preliminary tests we have conducted so far. We have also gone through their like properties and the tests which we are like conducting, and the ideas of coloration, different zones of the flame. So many things we have covered till now. We have another test as a preliminary test we conduct out. We call this test as charcoal cavity test. We also call this test as blowpipe test. What we have to do in charcoal cavity test? We make a hole in the charcoal. We have a charcoal block with us. We have a hole in it. We have this Bunsen burner. Definitely this Bunsen burner will not heat it directly, and if we like heat it directly, this will fall somewhere, right? This is a dried salt test we are conducting. This will fall somewhere. So what we have to do, sir, in order to save this particular salt, we have to turn the flame of this Bunsen burner into this direction where it can easily reach to burning it. So what I'm doing over here is blowing the it's a pipe, I'm blowing it, the flame will turn itself and this will be converted like this. So if upon, like, this is all we are doing, and don't need to basically memorize everything. It's just simple. Taking the idea is absolutely fine to all of us. Simply take the idea, that's it. So now again, there could be 2 things that if you are burning it from this end, this will be luminous flame or reducing flame. If you are burning it from this end, it will become an oxidizing flame, and it will, right? So let us see what happens. So guys, carbon is present there. Do remember that what is present there? Carbon is always there because of the charcoal cavity test. No, you are burning it in the presence of carbon there. We are burning the sample in the presence of carbon. So what will happen? Copper sulfate, when the test is performed, the following changes are taken. Why are we bringing Na2CO3 here? Moisten the salt in the cavity with 1 or 2 drops of water, otherwise this will blow away on heating. Use a blowpipe to heat this. What is the salt we are having? Make a small cavity. Do not apply pressure, otherwise it will crack. Fill the cavity with about 2.2 salt and 0.5 anhydrous. Okay, we are adding sodium carbonate also there, and why that will come to know. Always bore a fresh cavity for testing a new salt. Okay. So that the remaining ions should not interfere in the results. So we are bringing this reaction, everyone. So what reaction basically will happen? For the very first time on heating, the given salt will be converted into carbonate, leaving behind sodium sulfate. Then your carbonate upon heating gets broken down into Cu and CO2. Under the presence of carbon, it ultimately gives you metallic red color, which is of copper. So ultimately we are reducing up common given salt into its color. So why do we use Na2CO3? Now it is pretty much clear to me, and let me just basically write it over here, that Na2CO3 converts given salts into their carbonate, which are easily thermally decomposed, and reduced later to give metal. So basically we are producing the metal in this reaction. How do we produce metal? By simply reacting the given substance, and we produce the metal. Now in the case of zinc, also the same thing will happen. Zinc carbonate will be formed, zinc oxide will be formed. Zinc oxide on reaction with what? carbon will be converted into zinc metal with whitish or yellowish kind of appearance will appear. Then we have observations. Yellow residue. The same charcoal cavity test is done for others also. Lead 2 plus has yellow residue with when hot. So definitely yellow residue is because of the PbO, and which when broken down into lead at final will give you the gray metal appearance of lead. White residue with odor of garlic. Brown residue with cadmium. Yellow residue with hot, and white when cold. Sixth test is called as cobalt nitrate test. What is cobalt nitrate test? We actually use this test. Let us suppose some salt is not even giving us either of the test positively, where we can find any kind of deflection, change, measurement, confirmation. So what we have to do is we have to bring them to finally sixth cobalt nitrate test, where the residue of the charcoal cavity is white. Let us suppose the residue of charcoal cavity is white, where we are not supposed to, like, how can we get this idea which is there? Then we conduct the cobalt nitrate test right after the charcoal cavity test. We have to treat the residue with 2 or 3 drops of cobalt nitrate solution then, and when it is strongly heated in the non-luminous flame, which is your oxidizing flame, healthy blow pipe, observe the color of the residue. So guys, there we have the final touch of this preliminary test conducted for the cations. Right after that, we'll conduct a small break. We'll join back soon and we'll continue the classification of cations. We'll continue with their confirmatory tests later on. So have an idea that cobalt nitrate, we have cobalt nitrate on heating produces cobalt oxide, nitrogen dioxide and oxygen. This cobalt oxide gets basically connected to the, or like on heating it is like forming a double salt kind of compound with zinc oxide, which appears green in color. With magnesium it shows pink color. With cobalt nitrate it shows you blue color. This is how it works. And there we end with the, there we have ended with the preliminary tests are done, dry tests are remaining. Before starting your dry test, I would like to go for a break. We all will be having a small break. We'll join back soon. Then we'll continue from here. So what we have covered and what is remaining. What have we covered? So we till now have covered classification of anions. We have covered dry tests. We have covered their wet tests. Then right after it, what we have, we had preliminary tests of ions, where so many tests we conducted, all covered. We have now remaining classification of cations. We have now remaining, what should I call it? Classification is one part and another part is to distribute them. No. Then we'll do their confirmatory test. Confirmatory oblique wet tests of cations. This is what we have to do, right? So we'll do it in a while. Until then, we are having a a short break. We'll connect very soon, everyone. So don't go anywhere. Those who haven't liked the session, they please like the session. And also stay tuned. So we'll cover from here onwards in few minutes. Let me just give you a break. Hey everyone, so I'm back, and that was some healthy break we had. So I had, anyways, we all had fun. Meanwhile, hopefully, you all have written down the notes very well and are making the notes very carefully. So let us first know what we have covered till now. As we all know that anions we have covered till here, and now onwards we will try continuing cations, and for which preliminary tests have been covered. Around 5 to 6 preliminary tests were there which we have covered. One after one goes, like one which we have failed into will go for second one, second fails goes for third one, third fails goes for fourth one. That's how we go. And now we have come to the classification of the cations. So how have we classified them? Okay, so let us first read the all theory, because this is very important part, and believe me guys, I teach this chapter every year. I myself get, like, I forget these concepts. So this is the beauty of inorganic chemistry, that you have to keep on revising every time, otherwise you will forget it. Now we are performing the permanent, or like not permanent, we call them confirmatory tests for the cations. Cation their confirmatory tests. Okay. The cations indicated by the preliminary tests are given below. Above are confirmed by the systematic analysis. So guys, this is actually, they are very much connected to each other. The cations specifically are very much connected to each other. In anion, we used to conduct the separate tests for all the anions, depending upon what group they used to possess for. Now we have set of some cations. If group 1 cation fail, we'll go for if group 1 tests are not working, we'll go for group 2. Group 2 not working, we'll go for group 3. Group 3 not working, we'll go for group 4. And that is how we do the tests for all the group 4, 5 groups we have made. And then we have group 0 also, which contain ammonium ion. Okay, so I will read these points first of all, so you all must listen me. The first essential step is to prepare a clear and transparent solution of the salt. This is called as the original solution. We call it OS. Preparation of OS. How do we prepare a transparent solution? Now, to prepare the original solution, following steps have to be followed one after one in a systematic order. And in case of salt does not dissolve in a particular solvent, upon heat it, then try the next solvent. Number one thing, take a little amount of this salt in a clean boiling tube and now add a few milliliter of distilled water and shake it. If it gets dissolved, it belongs to some category. Let us say if it is not dissolving, then you need to heat the content present inside the tube so that it dissolves. There is a possibility that it still remains insoluble. The salt which we have taken in order to do the cationic analysis or anionic radical analysis, acid radical analysis, might be taking still as a PPT and it's not getting dissolved. Then what we should do? If the salt is insoluble in water, as detailed above, then now take a fresh salt in a clean boiling tube and now add dilute HCl in it. Now there's a possibility that it get dissolved, or let's say if it not getting dissolved, even if after adding the dilute HCl, then you boil the tube. Now observe whether it is completely dissolved or not. Now if it dissolves, it belongs to some if it dissolves, it belongs to some of the given category, and if it does not, then we have to do another test to prepare the original solution. We haven't got the original solution now. Let us suppose even after adding the dilute HCl, after heating it, it did not get dissolved. It is the time that we should now enter concentrated HCl, and not just concentrated HCl, you just heat it. And let us suppose even after heating it does not get dissolved. We have to follow the fourth step, that is, if the salt does not dissolve even in concentrated HCl, then we have to dissolve it in the dilute nitric acid. So if even in dilute nitric acid it doesn't dissolve, then we have to make the aqua regia. Aqua regia is actually made up of 1 mole of nitric acid to 3 moles of HCl, which is actually considered to dissolve all the like salts in it. And there is nothing that by chance cannot be dissolved in it. That will definitely be dissolved. So a salt that is not even soluble in aqua regia is considered to be an insoluble salt. Let us suppose it's not even dissolved even there, it will be considered as an insoluble salt. Here we go. There is a roadmap we have to follow, guys. We'll categorize all the salts into some category. We need to form a roadmap that we need to follow. This roadmap will give the idea about all the cations, their workings, and then finally segregation. So we had this original solution. Then original solution, if upon adding dilute HCl, and it gets precipitated, then it belongs to group number 1. Group number 1. Let us suppose if there is no HCl, no precipitate is formed. If there is no precipitate is formed, even we are getting like precipitate. If the precipitate is formed out of this dilute HCl solution, then their chlorides are precipitates. They are belonging to group number 1. AgCl, PbCl2, HgCl2. These all are considered to be group 1 cations. Number 2, if it doesn't get dissolved, we are passing H2S gas, hydrogen sulfide gas. The medium was already acidic because we have provided HCl there. Because of the common ion effect, only a few amount of sulfide ion will be there. So definitely now the salts which we are right now discussing about will be having lower value of KSP. Solubility product might be very less. So that even after adding a small quantity of sulfide ion, they will be precipitated out. And even if they not, then they belongs to group 3. We'll shift them to the next test. So if they precipitated out as a group 2nd, then in the sulfide, they are lead sulfide, cupric sulfide, arsenic sulfide. These all belong to the group number 2nd as sulfide their PPT. This is a very important bifurcation I'm telling you. This alone para will complete your complete classification, the whole classification of the cations. Let us suppose even after passing H2S through the acidic solution and none of the salt is getting precipitated out, then if no precipitate is taking to the original solution, then heat it with concentrated HNO3 and now cool it, and now add NH4Cl plus NH4OH solution in excess. Again, let me go there. We are heating it with concentrated HNO3. Let us suppose some impurity might be there, which will be getting oxidized as a volatile product, will be removed out of there. Then, to remaining solution, to this cooled down original solution, we will add two things, NH4Cl and NH4OH. Again, it's a common ion effect. We are trying to give OH minus ions in less quantity. Why in less quantity? Because common ion effect is working. We already are putting NH4 positive and Cl minus. So NH4 positive is working as a common ion. And then we are putting NH4OH. What happens after this? If hydroxides are the PPT. So first, chlorides were the PPT. Next, sulfides were the PPT. Third, group 3, hydroxides are the PPT. Let us suppose even after that none of the precipitate was observed. That means it doesn't even belong to the group 3. Group 3 precipitates are iron, aluminium, zinc, etc. We still have no PPT, then we'll pass H2S. In presence of H2S, we will be facing counter ion effect because already basic medium is maintained over there. Some OH minus was available there. On addition of H2S, some of the H positive ions will be eliminated out as water on reacting with hydroxide ion and will be giving S2 minus. Now the sulfides will be again coming in group 4. So group 2 and group 4 both belongs to the same type of salt. Sulfides category is same, anion is same. But the difference is lower KSP and higher KSP. Higher KSP is for the group 4 one, because for that we require more concentration of sulfide ion to get them precipitated out. That is what we are doing in group 4. See, then precipitates the nickel, manganese, zinc, cobalt, and let us say even if there is no precipitate, then add NH4OH, ammonium hydroxide. No, we are not going ammonium hydroxide. What we are doing? I don't know what is it, but we are giving them ammonium carbonates. We are doing solid ammonium carbonate. We have to check it out. What is it? Ammonium carbonate and ammonium hydroxide. So basic medium along with carbonates. So there we have some carbonates will be precipitate: strontium, barium, and calcium. And anyways, we'll read them one by one now. Let us come to the classification, everyone. Let us come to the classification. I have already told the classification, how does it work, and I'll explain this classification one more time over here. We have what we have. We have group number 1 where chlorides are the precipitates. These are the ions: Hg2 2+, which is Hg plus, mercurous salt, lead 2 positive, silver 1 positive, and we got the precipitate over there. Even with dilute HCl, their sulfide, their chlorides are the precipitates. So you must see that these are the precipitates. The AgCl is white PPT, PbCl2, I don't know, whitish might be, yellowish might be. Then we have Hg2Cl2, another PPT. So let us suppose if it didn't go as PPT and it is still soluble. So we are adding some YAS in here. Now let me check what is YAS. So YAS is called as yellow ammonical sulfide solution. So basically we are providing them sulfide ion. Okay, what we are providing them is the sulfide ion. Yellow ammonium sulfide. So one of the source of sulfide ion. So there are two things we have. One of them is which are soluble in, not soluble, which are like second is which are insoluble in YAS. So they will form sulfide. They will form sulfide as precipitate. CuS, PbS, HgS, they are black. CdS is yellow. Bi2S3 is brown PPT. As2S3 yellow PPT. Then if these are the compound, these are called as category in second B. These are second A, these are second B, which are still soluble in YAS, ammonium yellow solute. Then we are passing acidic H2S and then they get precipitated out. Their examples are these arsenic, antimony. So arsenic, antimony and tin are the three examples, and there are multiple variation of oxidation state. Like arsenic is 3+, 5+, antimony 3+, 5+, tin 2+, 4+. Yaar, move forward. Then if let us suppose somebody is not getting precipitated even in the YAS, yellow ammonium sulfide, yellow ammonium sulfide, then you have to make it reacted with the presence of hydroxide, and hydroxides we are providing in the presence of NH4OH and NH4Cl. So we are trying to provide it very less amount of OH minus. Whoever gets precipitated are the aluminum, iron and chromium. These are the precipitations we are getting: chromium, aluminum, iron. Right after that, if we are not even satisfied with this and we also have a soluble part, we will add H2S, and basic solution is already, because of these, this is already basic. So basic will produce another sulfides with high concentration of sulfide. So group 4 sulfides have higher KSP values than group 2 sulfides, so that group 4 sulfides are becoming precipitate quite later with some sufficient amount of sulfide ion concentration, while group seconds are becoming very easily. So their sulfides are getting very easily. Group 5, then comes group 5 where barium, calcium, strontium cations are there, and in the presence of ammonium carbonate and ammonium chloride and ammonium hydroxide maintaining the basic medium as well as the carbonate ion, they form their carbonates as the PPT. Examples are calcium, barium and strontium. They are whitish in color. Then we have group number 6. Group number 6 is the one which are no group reagent, where we cannot get any precipitate form. We will not get their precipitate form. They always remain insoluble. They always remain soluble. Then we have group 0. Group 0 is actually ammonium ion. What is group 0? That is an alkali solution of a KOH or NaOH. It removed as a NH3 gas. Since there is no precipitate formed here, we have categorized it under 0 group, because this in the basic medium it releases itself as ammonia gas. This is the classification of group wise classification of all your cations. I hope this part is absolutely clear to all of you, and even if it is not, then just quickly revise it by your own end, and believe me, you will be highly comfortable in it. Now we have the last part of this entire chapter, where we'll be going for the confirmatory test of each and every individual cations. So we will start it from the group 1 cations first. Group 1 cation contain what? Okay, we are having group 1. Before group 1, we have some important questions with us, that why we have put NH4 positive as group 0, not in the any other group, because it doesn't give any PPT. It simply gives you a volatile product as ammonia gas. We kept it into a group 6. We have another thing which is called as second is lead 2 plus is capped into two side. If you people have observed this, because I did it, that we saw that how come lead over here is in two-way, like over here and over here also. Why? So lead chloride is insoluble PPT in the cold water, but upon heating it becomes soluble in the hot water, and Pb2 plus ion is group 1 filtrate. Now its sulfide in group 2 will be a PPT. Lead sulfide is a black PPT. Next, concentrated HCl cannot be used in the place of HCl, dilute HCl in group 1, because if we are using concentrated HCl, then it will form a complex out of it, and this complex is actually soluble in water. So it will let it be a AgCl as a precipitate, but this precipitate on reaction with concentrated HCl gives you a soluble complex, and that's why we do not prefer to use concentrated. We use dilute HCl in group 1 identification, where chlorides will become our precipitates, PPTs. Next is, so if Ag plus and Pb2 plus are present, then it will give negative test due to dissolution of PPT. So that is why we don't use concentrated HCl, we use dilute. We are coming for one by one confirmatory test of all. For first, we will start doing the confirmation test of ammonium ion. Let us just start. We have confirmatory tests from starting from 0th group. The 0 group ion is your ammonium ion, sorry, not ammonia. An ammonium ion on reaction with ammonium ions on reaction. We have ammonium ion with us, everyone. So the very first thing that we do is ammonium ion is reacted with 1 to 2 ml of sodium hydroxide, where ammonia forms ammonia gas, ammonium ion form ammonia gas, which is eliminated out, which leaves this solution out. Then we have pass the gas through Nessler's reagent. A brown pipette is obtained. You must know what is Nessler's reagent. Nessler's reagent is actually basic, or let us write alkaline potassium mercuric iodide. Alkaline potassium mercuric iodide is called as Nessler's reagent. Here it gives a reaction where mercuric oxide will be formed, HgO, with HgNH2i. This is called as basic mercury second amido iodine brown precipitate, along with evolution of 4Ki dissolved over there and water. Let us solve some questions on the same. We had 0th group with us. 0th group cation is ammonium. Ammonium salts on heating with slaked lime liberates a colorless gas X. Identify the correct statement. Guys, you know this reaction. So any base it reacts with, let us suppose NH4Cl is the compound. On reaction with calcium hydroxide, which is slaked lime, it will form CaCl2 plus ammonia gas plus water. So this is your ammonia gas which we are talking about. It turns red litmus and produce dense. It turns red litmus blue, correct. Produces white dense, correct. Its aqueous solution actually does it. And it turns filter paper moistened with mercurous nitrate black. What is it doing with mercurous nitrate here? And it gives intense blue color with this. That is what I know. This forms CuSO4 aqueous. If it is reacted with ammonia, forms a complex CuNH3 whole 4 like this sulfate. This is deep blue. Initially also it was blue, but this is deep blue, very deep blue. We have when it is passed through Nessler reagent and a brown complex is formed. Yeah, that is what we just studied. I think all of them are correct, but I am not getting. Turns filter paper moistened with mercurous nitrate black. Okay, some filter paper which is actually moistened with mercurous nitrate. Maybe it will form the same thing like this. Mercurous nitrate is there, then it will form, maybe this compound will be formed. Anyways, all of these are correct. Nessler reagent is, I told you Nessler reagent is alkaline potassium mercuric iodide. So this is correct, B. Next we have analysis of lead 2 positive ion. So lead 2 positive ion confirmatory test is already conducted once. How? In group 1. So in group 1 we have lead chloride, which hot solution is actually dissolved soluble. In presence of Ki, it gives you lead iodide, which is a yellow PPT, one thing. Yellow PPT is soluble in boiling water and reappears on cooling as shining crystals. So this is one of the tests. Another could be on adding potassium chromate K2CrO4. It forms lead chromate, which is another yellow PPT. And this lead chromate on reaction with NaOH basic gives you Na2PbOH whole twice, which is soluble in water. So guys, we had initially lead chromate as yellow PPT, which upon adding base into it forms a soluble complex. So this is the test of lead 2 positive. I don't know what is it. Okay, mistakenly. Third is, if a white precipitate of lead sulfate is given, it is formed on the addition of alcohol with dilute sulfuric acid. So PbCl2 plus H2SO4 gives you PbSO4 as a white precipitate. This PbSO4 on reaction with acetate ion forms again a complex which is lead ammonium tetraacetoplumbate, which is soluble. So initially it was insoluble. PbSO4 was insoluble in water as white PPT, but its white PPT becomes soluble in the presence of ammonium acetate. That's simple. So these are the tests of lead 2 plus. A metal nitrate, we have a salt of metal nitrate that reacts with Ki solution to give a yellow. So we know what is it. Yellow was PbI2, which upon this excess of more concentrated solution, Ki dissolves, forming a solution. The cation of metal nitrate is what? Okay, so what we have, everyone? We have lead nitrate with us. We all have lead nitrate, PbNO3 with us. This lead nitrate on reaction with potassium iodide gives a double displacement kind of reaction which will form PbI2 and KNO3. This is aqueous, this is solid, this is yellow PPT. But there is a problem, guys. If we add more Ki in this solution, then this solid PPT is no more a solid. This in axis gets it converted back into PbI4 whole 2 minus, so K2 PbI4, and this is aqueous, this is soluble. So there's a soluble complex over here is formed, and that is lead we are talking about. Oh yeah. Next question is, consider the following observations. Mn plus some ion is there on reaction with HCl, it gives you white PPT, and it is water soluble on heating. Definitely this is lead chloride. Lead chloride. PbCl2, upon heating it gives you PbCl2 aqueous. So initially it was solid. Then on reaction with chromate ion, it gives you PbCrO4, which is a yellow PPT. Correct answer is C. Very easy question. And since we are studying it for group 2 or group 1 only, and especially about the lead, answer will be lead only. Next is group 2. Analysis of group 2 cation. What do you think? What should we do? Group 2 cation are there, whose sulfide is like, which can get precipitated even in the lesser concentration of sulfide. Okay, sorry, somewhere else. Yeah. So group 1, group 1 is absent in excess of water to the sample tube. Warm the solution, pass H2S hydrogen sulfide, 1 to 2 minutes, shake it. If the precipitate appears, then it indicates the presence of group 2 cation. And if it is not, then pass more H2S through the solution to ensure the complete precipitation and separate the precipitate. If the color of the precipitate is black, it indicates that it's the presence of Cu2 plus or lead 2 plus. If it is yellow, then it can be a presence of arsenic as indicated. So take the precipitate of group second in test tube and add excess of yellow ammonium sulfide solution to it, and now shake it in the test tube. If precipitate is insoluble will go for second A, copper group, and if the precipitate is soluble, it indicates the group second B, like arsenic group. So confirmatory tests for the group second A group are given here. Group, where is it given? Here. So lead sulfide precipitate, lead sulfate with HNO3 gives nitrate. I don't know what is it, where we have come here. How can again this came? Oh, no, something else. Something else was here. Okay, next question we must go. White crystalline substance dissolved in water. On passing H2S, a solution, a black PPT. Black PPT means it could be copper or lead. So simply I'll give it lead. Let's not move ahead. Lead is the correct answer. We have analysis of Cu2 positive ion. Cu2 positive ion, which is a part of group second cation. So group second cation is copper. Sulfide will be a PPT, but in presence of HNO3, it gives you cupric nitrate along with nitric oxide and sulfur and 4H2O. Now the sulfur which is produced over here can react with nitric acid, giving you sulfuric acid and nitrogen oxide. Cupric ion with sulfate ammonia forms a complex like this, or this complex is the ammonia will form CuNH3 SO4, which is a soluble complex, deep blue. So the blue color over here will convert it to deep blue. Next is, if the blue solution of acidification with acetic acid, and then by adding potassium ferrocyanide K4FeCN6 solution gives a chocolate coloration. Oh yeah, chocolate coloration. Formation of copper ferrocyanide. This is this. So guys, K4FeCN6, we are getting reacted with our copper sulfate. So copper with its sulfate, this on reaction with acetic acid gives copper sulfate plus ammonium acetate. Copper sulfate on reaction with potassium ferrocyanide. Potassium ferrocyanide, because this is second Fe2 plus are called as we call it ferro because it is ferrous, and it is called as ferry. Ferry means ferric. Ferric. H2S in the presence of HCl precipitates group 2 but not group 4. Why is it so? H2S in the presence of HCl, means in common ions, it is doing second because maybe HCl decreases the concentration of sulfide ion, and since HCl gives lesser concentration of sulfide ion, and group second sulfides, I told you, they have lesser Ksp value, they can easily be precipitated out. The correct answer should be C as per me. When excess of NH4OH is added to the aqueous solution of copper sulfate, in instance blue color is developed. What is this? Because of the ammonia complex of copper here, which is CuNH3 2+. This is Yellow ammonium solution is a suitable reagent for a separation of. Now you guys need to identify which one of them is group second A and second B. Second A were the which were insoluble in YAS, and second B were soluble in YAS. So this is something that we have to check about, because even I forgot it. I have forgotten it, man. I don't remember it very easily, bhaiya. So guys, second A were insoluble, they got precipitate, but the soluble in were like antimony, arsenic were one. So other cadmium, lead, all they come under same category. My answer should be D, because bismuth, they all come under same, and copper, these all under same. I think D is the correct. So for this you should follow that classification part. In group second we had group second A, group second B. Based on that we have classified it. Then we have analysis of group 3 cations. We have group 3 cations with us. Group 3 cations. What does group 3 cation has to say? So analysis of group 3 cation. We all know group 3 cations are the hydroxides. So in the absence of group second radical, we need to add 2-3 drop of concentrated HNO3, so that the Fe2 plus gets oxidized to Fe3 plus. And now we have to heat the solution for a few minutes. After cooling, we have to add small amount of ammonium chloride with an excess of ammonium hydroxide. It smells of ammonia solution till it smells of ammonia. Shake the test tube. If a brown white PPT is formed, it indicates the presence of group 3 cation. Confirmatory test of this is done. This is the chemical reaction, not this. Where is iron? This is the chemical reaction happening. FeOH whole thrice. So let's test one aluminium ion first. Test for aluminium ions. When the solution containing aluminium chloride is treated with sodium hydroxide, a white gelatinous precipitate of ammonium hydroxide is formed. This white gelatinous substance, which is actually a kind of precipitate, is soluble in NaOH, sodium beta aluminate. And this test is called as lake test. I don't know what is it doing. In the second test, when we add blue litmus is added, a red coloration is obtained due to the acidic nature of the solution. Where is the acidic nature? Why? Okay, maybe AlCl3. AlCl3 is actually a salt of strong acid weak base. Salt of strong acid weak base. So on addition of ammonium hydroxide solution drop by drop, it becomes alkaline and aluminium hydroxide is precipitated. So aluminium hydroxide absorbs the blue color from the solution and forms insoluble adsorption complex named lake. Thus a blue mass floating is obtained. Is called as a lake test. We call it as a lake test. So let me just again clarify this part to you. since we already had a acidic aluminum chloride solution which is acidic in nature and it converts blue litmus into red. So this already had converted the blue litmus into red. So now if you add drop by drop basic solution over there in the presence of this the red colored litmus that was already converted due to the acidic nature of this, अब now suddenly converts back into blue and it looks like blue color is complexing over there and mass of blue color is floating there, called as lake test. Then we have Fe3 plus ion test. Reddish brown precipitate of ferric hydroxide dissolves in hydrochloric acid and ferric chloride is formed. This reaction is here. Ferric hydroxide reaction with HCl forming FeCl3 and water. So when the solution containing ferric chloride is treated with the potassium ferrocyanide. Okay, this is some important test, everyone. Please remember this part. I'm just star marking it. Star marking it, everyone. Please read it out. All three are very important. Let us first go through the A. When the solution containing ferric chloride is treated with potassium ferrocyanide. Okay, we are treating it potassium ferrocyanide. A blue precipitate coloration is obtained. What is it, by the way? 4Fe3 plus K4FeCN6. This is normal potassium ferrocyanide. Reaction gives you Prussian blue precipitate. Prussian blue is something which we have studied in previous class also. This is Fe4FeCN6 whole thrice. We don't need to learn down. I told you that this is how we can learn this. Fe is present in +3 state and inside it is in +2. This is called as Prussian blue. So if the potassium hexocyanate ferrate, the one which is formed over here, which is called as this one, is added in the excess of the product, then composition becomes KFe and this soluble Prussian blue we get, soluble Prussian blue, KFe. Okay, iron, few of the irons are replaced by potassium, or few more are going for the complexation kind of, and this tends to form a colloidal solution which is soluble Prussian blue and cannot be filtered. To the second part of the solution, if we add potassium thiocyanate, so iron 3 plus with potassium thiocyanate forms a complex called as FeSCN2 whole plus, which is blood red in color. Some questions here. NH4Cl is added to a solution of NH4OH. Why? Dissociation of NH4 increases? No, not at all. OH minus of concentration increases? Not at all. Common ion effect. That concentration of both, not at all. The concentration decreases? Yes, common ion effect. Very simple. Common ions are generated as ammonium ion, like this. Intense blue precipitate of Fe4, FeCN6 whole thrice and potassium hydroxide is why, when mixed with, gives what? What? Intense blue color of Fe4, this Fe4, FeCN6 whole thrice. This is Prussian blue, and FeOH whole thrice reddish brown PPT. Okay, already blue solution hai. This is your Prussian blue, and with ferric hydroxide will give you what? It gives you FeOH whole thrice. And this is the only soluble part, everyone. See, let me just explain this part. Fe4, FeCN whole 6 whole thrice. This is +2, this one is +3. So on reaction with KOH, the only soluble part will react. It will make what? K4 FeCN6 plus, let's say this is 3 on that's it. Oh no, yaar. Second should be correct answer. Reddish brown PPT is formed. Turbulence blue is what? Okay, so there are two types of things. I'll explain this part. One of them is called as Prussian blue. Prussian blue. And then another one is called as Turnbull blue. So guys, what is Prussian blue? Prussian blue is ferrocyanide. And what is this? And this is your ferrocyanide. Now you might be wondering what is the difference between ferro. So ferri means Fe3 plus. Ferro means Fe2 plus. So this will form a complex FeCN whole 6. The charge is over here is plus 2. This is minus 1. Total minus 6. Minus 4 charges here. So guys, you just cross multiply with the charges. You will get the formula Fe4 FeCN 6, and this is whole thrice. This is called as Prussian blue. Coming to Turnbull blue, ferro means Fe2 plus, ferri means Fe3 plus, Cn whole 6, and this will be acquiring, this is positive 3, this is minus 3 charge. So this is 2, cross multiply, this will become what? Fe3 FeCN whole 6 2. Check it out, everyone, check it out. That is Turnbull's blue versus Prussian blue. Learn them, remember them. This is the trick, this is the technique I showed you. That's how we do. I hope this part is pretty much clear to all of us. I only can hope, as nobody is responding me in the chat box, then I can only hope it. So see, ferrocyanide. This is plus 2. Yeah, ferrocyanide will be the correct answer. Now try this question. Iron hydroxide and completely separate by. Okay, guys, you do it by your own, and then I'll come and give you the answer. I'm coming back after drinking of water. Allow me a while. Yeah, guys. So where were we up to? I gave this question for you to solve it, and hopefully some of you have solved it already. Look at this question. FeOH whole thrice and CaOH whole thrice. Well, see, FeOH whole thrice on reaction with HCl gives FeCl3 plus water. So 3. But CrOH whole thrice. चलो कुछ This will also give CrCl3 in water. Then what's the point, man? We had to find out. We need to find out something which doesn't discriminate. Sorry, it does discriminate between these two. Oof. Okay. There is one more thing which we can do. So guys, this is like I'm checking it here in my repository, this question, though I found that yeah, these two are the very similar reaction, will not give any difference as such, but there is some compound that can make a difference, which is NaOH H2O2, because this is actually what? This is an oxidizing agent. So in basic medium and in iron OH whole thrice H2O2, even in presence of OH minus, there is like no reaction. The reason behind it is very simple, that iron is already in positive 3 oxidation state, can't be oxidized. But if we make chromium hydroxide for the same reaction in the basic medium, it goes to CrO4 2 minus, which is positive 6 oxidation state. From positive 3 oxidation state, it is going to positive 6 oxidation state. So it may work, and then it will be reduced down H2O2 into H2O. So this is how the reaction goes. So we can say that this is soluble in this medium and this is insoluble. Correct answer should be C. Now we should check what is the correct answer given. Let us check what is the correct answer given. C is correct, right? C is very well correct. Finally, after group 1, group 2 and group 3, we have arrived to group number 4, which will also having sulfide ions as their precipitate. But here, more concentration of sulfide ion will be used. That is why they have higher values of Ksp. So we have group sad ion is absent after passing H2S gas. Then if there is group 3 is absent, we are passing H2S gas in the solution. Since the solution is already basic, more amount of sulfide ions will be created. The H positive produced by this weak electrolyte of H2S will be consumed in the basic medium. So sulfide ion will be more produced by the counter ion effect. In this counter ion effect, if a precipitate appears white, black or flesh colored, it indicates that the fourth group cations are precipitated and their sulfides are precipitated. And observe the color of the precipitate. White color is indicating the presence of zinc, flesh color is presenting the manganese ion, and black color is because of the nickel or cobalt ions. Now please write this part down and remember this every time. Which gives what? We have analysis of zinc 2 positive ion, the confirmatory test for zinc 2 positive ion, everyone, the wet test for zinc 2 positive ion. How does it confirm with? We have zinc sulfide, which gives a white PPT. Upon reaction with HCl, it's soluble and it gives you zinc chloride as a soluble salt, and hydrogen sulfide gas is released, which is actually, which has a rotten eggs kind of smell. So you can see how we can predict this thing out. On addition of sodium hydroxide solution, it gives a white PPT. Zinc hydroxide, Zn 2 positive ion gives you ZnOH whole twice, which upon further reaction with this gives a soluble salt of sodium zincate. So guys, this is PPT, and then again it becomes soluble. So this is the test where we can identify that something is actually zinc, whose white PPT was initially formed and then it is again getting dissolved. We also have another test here where we are supposed to get this compound reacted with ferrous potassium ferrocyanide. Potassium ferrocyanide reacts with zinc chloride to give you Zn2FeCN whole 6 plus 4 KCl. So Zn2FeCN6 will be the compound, zinc ferrocyanide, and it's a white PPT. The white precipitate. So this confirms the presence of zinc. Let us try some questions here, everyone. To increase this significantly the concentration of free Zn2 positive ion in the solution of the complex in ion ZnNH3 whole 4 2 positive, and this we have to increase significantly this complex ion. Add solution to same what? So if we have to bring the reaction to forward direction, no, backward direction, we have to consume consume it according to Le Chatelier principle. If you can consume it, and reaction goes backwards. So which will be the correct answer? I think B. B only is HCl can consume ammonia. Ammonia is basic, HCl is acidic. Then we have test of nickel 2 plus. So we have the black precipitation of nickel sulfide dissolved in aqua regia, and the reaction takes place as follow, that we are having nickel sulfide, which is a precipitate, and upon reaction with HNO3 and HCl it gives you nickel sulfide, nickel chloride, unless it doesn't get dissolved in either of the acid or a base kind of thing from here. So after treatment of aqua regia, nickel chloride is obtained, which is soluble in water, and when we add dimethyl it forms a complex like this, which is a red color complex. So guys, do remember it, that reaction of glyoximate, it's a red color PPT. Reaction of Ni2 plus with glyoximate gives what? Dimethyl glyoximate. Red color PPT will be observed. And this kind of complex is there where kind of tetrahedral intermediate, not tetrahedral, square planar complex is formed. Now we have the final, the group 5, and since group 0 is already completed from our end, we have group 5 with us, everyone. Let's welcome group 5. So what does it include? In group 4, if group 4 is absent, then take the original solution, add some solid NH4Cl and excess of NH4OH. So, and followed by some ammonium carbonate are also providing. So initially we are bringing it to small amount of NH4Cl, then excess of NH4OH. Common ion effect will already there, working there, so a very few amount of OH minus will be obtained. Then ammonium carbonate will give you, so whatever the precipitate of group 3 is there, or group 3 cation is there, which would have earlier precipitated, but if not, then right now we are providing more NH4OH, so that if it is there it can be precipitated, but if not, then definitely it's a group 4 cation, could be group 4. So we are going for the test of group 4. We are adding ammonium carbonate. Carbonate ion reacts with these ions of barium, strontium, calcium, and giving the respective carbonate as precipitate. Now since carbonate is precipitated, this is the confirmed that barium, strontium and calcium might have been there. Now preserve a small amount of these precipitate for the flame test, and then we'll do the flame test and we'll confirm what was that and distinguishing between these barium, magnesium and strontium. So now where is it coming from here? Okay, mistakenly. So let us suppose barium we have to confirm. So guys, we all know that barium upon flame test gives which color? Barium gives you apple green color. I remember apple green. Oh my god, apple green. Where is apple green here? I want to see apple green here. A grassy green color confirms the presence of barium 2 plus. So take a platinum wire, dip it into concentrated HCl, heat it strongly until the wire doesn't impart any color to the non-luminous flame. So non-luminous flame is your oxidative flame. Now dip the wire in the paste of this concentrated HCl and heat it in the flame. A grassy green color of the flame confirms the presence of barium. This is the B, and A is another test in which we are confirming the presence of barium 2 positive ion. How? Let us check. Barium carbonate is allowed to react with acetic acid, which gives you barium acetate and water and CO2. Barium acetate on reaction with potassium chromate gives you barium chromate, which is a yellow color precipitate. Another confirmation test. Calcium, how do you identify the presence of calcium? So solution of the 5th group precipitate with ammonium oxalate solution. So calcium with reaction with calcium on reaction with acetic acid gives you calcium acetate, water and H2O, then H2O and CO2. Then calcium acetate on reaction with ammonium oxalate produces, what is it? COOCA, which is calcium oxalate, and it's a white precipitate and forms ammonium acetate. Flame test is pretty easy. Brick red color will be observed. See, brick red color. Very good. One question. If crimson flame is given when inorganic mixture, when an inorganic mixture is tested or flame test, it may be due to. So crimson flame, crimson red is given by strontium, I guess. Yes, strontium. Because potassium gives violet. We have brick red for calcium. We have apple green for barium. And we have strontium for crimson red. Next is he has not even come yet. Yeah, everyone. Yeah. So there we have the brick red color of Bunsen is coming from calcium salt only, no doubt. A very easy question. Then we have analysis of magnesium 2 plus. Analysis of magnesium 2 plus. So just give it a read out everyone, please read out it, and then we'll continue. Please read out. Wow. So read it everyone. So hopefully you all have read it down, and this was the final part of today's lecture, which is magnesium, all belonging to group number group number sixth. So what is the meaning of sixth group? Sixth group are the one which are showing, I guess, no precipitate, I guess. Their salts are not precipitated even till magnesium carbonate. So what we have to do is, if a group 5 is absent, that means its carbonate will also be soluble, and that is magnesium. So in water and in the presence of ammonium salts, because the equilibrium is shifted towards the right hand side, so what is happening here, yeah? Group 4 is absent. This solution may contain magnesium carbonate, which is soluble in water in the presence of ammonium salt. Okay. So ammonium salts were there, ammonium were there in high concentration. So because of ammonium, it will move from bicarbonate here, HCO3 minus, along with NH3. The concentration of carbonate ion increases, required to produce a precipitate of not attained. When disodium hydrogen sulfate solution, what is disodium hydrogen sulfate solution here? When disodium, not disodium here, okay, Na2HPO4 is added to the inner walls of the tube, scratched, and they are scratched with glass rod, white crystalline precipitate of magnesium ammonium phosphate is formed. MgNH4 whole PO4, MgNH4 PO4. That confirms the presence of magnesium ion. And note down the observation and the interferences. Note down that the observations and the interferences of the qualitative analysis in tabular form as given in the specimen record, page 114, 115. Do follow it on. Please kindly go to the lab manual and find it there. So sometimes precipitation of magnesium ammonium phosphate appears after some time. So warm the solution and scratch the sides of the test tube by adding sodium hydrogen phosphate solution. So guys, that is it. That was group number 16, which group number 6, where none of the ion worked there, none of the anion could give the precipitate. In such a way, we had magnesium with us, and we had to make this reaction with some other reagent, which is disodium phosphate, disodium hydrogen phosphate, which later on like when it is poured through along with the walls of the test tube, reacts with magnesium on scratching, produces a white color crystalline solid, white color precipitate, which is magnesium ammonium phosphate. And that is it, the end of this chapter. Do revise it quickly. So let me just give you once an overview about the classification once, because that is the only part. If you can clear your classification part, then everything out of whatever I have taught to you today, literally this 4-hour journey will be highly successful to all of us. Let me just give you a quick recap of the classification. So now classification, let us start once again, everyone. We read today all 6 categories, 6 groups, in which individual groups has a different type of precipitate as cation. So number 1 is called as group 1, in which chlorides are the precipitate. The clear examples are Ag and Cl, AgCl, Ag plus, Pb2 plus, Hg plus 1, Hg2 plus. These are the examples where chlorides are precipitated. We had lead present in both of group 1 and group 2. Group 2 are the one in which sulfides are the precipitates. If you have insoluble salt as in a precipitate in chloride, then it will belong to group 1. If it is getting still soluble and you are not getting any precipitate, you need to go for passing H2S gas through the solution, which is already acidic. So that is why common ion effect will work. Lesser concentration of sulfide ion will precipitate, and lead will be precipitated down, PbS as black PPT. Also, copper also has the same category of cupric sulfide as black PPT. Cadmium sulfide is yellow PPT, and similarly some kind of these comes under the category of group 2. Now group 2 also has further two categories, group 2A, group 2B. Group 2A are the one which are insoluble in YAS. They immediately get the precipitate. YAS is yellow ammonical solution, yellow ammonium sulfide solution, the same NH2 NH3 NH4 whole twice S. This solution dissolves some of the precipitates of the sulfide, then they are group 2B. So group 2B are the arsenic, antimony and tin cations, and group 1 are the copper, lead, mercury, Hg2+, bismuth and cadmium. We then pass hydrogen sulfide gas through it. No, we are not passing hydrogen sulfide gas. We are just pouring it, NH4Cl and NH4OH in the solution. Then after passing these two solutions, basic solutions, the quantity of OH minus which we are getting precipitated by the cations, they are considered as group 3. Group 3 cations which get hydroxide as PPT. The examples are iron, Fe3+. We have aluminium, Al3+. We also have chromium 3+. These are the examples. Later on we are like passing what we are passing now. We already have the basic solution. Then again we are passing hydrogen sulfide gas, similarly as we are doing in the step 2 for group 2 cation. Now after passing sulfide gas, this H2S hydrogen sulfide gas, we will be having a counter ion effect because the solution is basic. We are providing acidic gas. H plus and OH minus will be consumed and sulfide ion will be there in the higher concentration. So now those kind of salts, those kind of precipitates which will be having higher value of KSP will be precipitated down. And these examples are this zinc sulfide, manganese sulfide, cobalt, nickel sulfides. Then after sulfides, let us suppose still some salt is soluble and is not giving any PPT. We'll right now pass it through the solution of ammonium carbonate, ammonium chloride and ammonium hydroxide. Now this solution has carbonate as PPT, and the common examples of this are calcium, strontium and barium. Their carbonates are precipitated down. Their confirmatory test we have already covered. Let us suppose even right after this is group number 5 we are discussing. Even group number 5 are not giving you any PPT. Then they will be passing through group number 6, which has none of them as soluble potassium, magnesium and sodium. And we also have covered the test of magnesium, where magnesium was later on this anion was this cation or this solution was reacted with disodium hydrogen phosphate, which later on gave you magnesium hydrogen phosphate as a precipitate, and magnesium ammonium phosphate was the precipitate in presence of ammonia gas, which was present in the ammonium ion from here. Then at last, zeroth group is ammonium ion, and since ammonium ion does not give any precipitate, we have kept it in a very separate category, because ammonium ion on reaction with basic medium gives you ammonia gas, which is liberated out, can be detected by various methods, such as reacting it with HCl gives NH4Cl white fumes, or we can get it some other way are also there. Complexation can be done. You know what aqueous solution of copper sulfate is blue? You pass ammonia, it becomes intense blue. That is also one of the confirmatory tests for ammonia. So that is what we can do. So that is it for the day. We have completed this chapter now. Hopefully you all have these notes with you. Kindly get the notes on our Telegram channel. The link is given in the description, everyone. Do like the session, love us a lot, and believe me, stay with us. Keep faith and keep belief in your teachers. We will get your complete syllabus done by the end of December, which is like 1 month or kind of 15 days prior to your exam. And then also we'll run some very specific and very useful series, such as PYQ solving series, and one more is there, that is most predicted questions I provide you. Believe me, last time I conducted these sessions on Unacademy JEE and Unacademy Atoms, those went literally very successful. Many of the questions matched with my expectations. So kindly subscribe us, stay connected with us, join our Telegram channel, and I'll keep you updated. Okay, so bye bye, take care everyone, bye bye.